The question drifts in softly, as if it has always been there, suspended like dust motes in late afternoon light. What if humanity is not the first? The idea feels both radical and familiar. Radical because our sciences teach us to measure, to root ourselves in evidence, to respect the absence of proof as meaningful. Familiar because the thought that others may have walked this planet before us seems to echo from the stones themselves, from every canyon and basin that has held life longer than our line has stood upright. The whisper is not loud nor demanding. It is a quiet thought that arrives like a tide against the shore of certainty. The earth is old. This is the baseline fact that steadies every speculation. 4.5 billion years stretch behind us, and in that immensity, modern humans too. 100,000 years of upright presence? 10,000 years of agriculture? A mere few centuries of industry appear almost as an afterthought. Imagine a thick book, its spine weathered and its pages smelling of minerals and dust. Our entire recorded history would fit in less than a letter on its final page. Against such scale, the possibility that other stories have been written and erased no longer feels far-fetched, feels almost inevitable. Yet what would it mean to call something a civilization in this deep-time sense? Not cities as we know them, not writing on clay or glass towers, but the presence of intelligence organized enough to alter the world in durable ways. A civilization is not simply a culture or a lineage. It is a patterned force that leaves behind a signal distinct from the randomness of nature. When framed this way, the Earth becomes not just a planet of life, but a palimpsest-layered text where ink is scraped away and written over, each new message faintly impressed upon what lies. Beneath, the first challenge is recognizing that absence is not certainty. The geological record is profoundly biased toward the durable, the fortuitously preserved. Even the bones of vast herds are ground to dust unless quickly entombed in sediment. Entire forests disappear without trace. Civilizations, if they arose tens of millions of years ago, would have faced the same erasures. Plate tectonics recycles crust. Rivers scour floodplains. Glaciers grind stone to flour. In the end, only fragments remain, and even those often speak in riddles. The silence we observe is partly Earth's own editing. Still, the possibility insists on attention. If such civilizations existed, what would they leave behind? Here, the mind wanders through plausible traces. Chemical signatures in stratocarbon. Isotope excursions from unnatural combustion, spikes of rare metals beyond volcanic norms, synthetic minerals unknown to biology, yet these too can be mimicked. Nature herself is a great inventor. Asteroid strikes scatter iridium, volcanism alters. Atmospheres, oceans turn anoxic and leave black shales thick with carbon. To claim evidence of intelligence requires not one marker but the convergence of many, layered like harmonics in a chord. And so, the whisper remains just that, an idea, gentle question that rests on the edge of science. It does not demand belief. It does not overthrow the known. Instead, it asks us to slow down, to feel the vastness of time, to consider that our species might not be singular in the deep history of this world. You might imagine Earth holding its breath, waiting between epochs, resetting, allowing the slate to be written upon again. The possibility does not erase our uniqueness in this moment. It adds depth to it. It suggests that our presence, like any other, is fleeting yet meaningful, a verse in a poem that began long before us and may continue long after. Whether predecessors existed or not, the question draws us into a larger intimacy with time itself. It makes the ground beneath our feet feel less like a static foundation and more like a living archive. Restless, imperfect, always revising, and, if there were whispers before U.S. civilizations whose names will never be known, then their greatest gift may be precisely their absence, a reminder of how fragile endurance is and how extraordinary it is that anything at all can persist across the tides of geology. In that absence lies both humility and wonder. To begin imagining forgotten civilizations, one must first reshape how time is pictured. We are accustomed to rivers linear, directional, flowing steadily from a mountain spring to the open sea. Human stories are told like this: beginnings, middles, ends. But geological time refuses such simplicity. It is not a river, it is an ocean. Currents drift in many directions. Depths overlay one another. A storm at the surface may never touch. The abyss. When one thinks in terms of the ocean, the idea of lost civilizations feels less improbable. For the surface of human time is only a thin ripple upon an abyssal plain. Consider, the Earth is 4.54 billion years old. Life itself emerges by 3.5 billion years ago, perhaps earlier. Complex multicellular organisms appear by about 600 million years ago. Dinosaurs rise and vanish in a span that feels incomprehensibly long to us, 160 million years. Yet even that, rain, is only a chapter. Modern humans, by contrast, live entirely within a geological instant. If one compressed Earth's history into a single year, our species would appear in the last few minutes before midnight on December 31st. Our cities, our satellites, our written languages, they would occupy mere fractions of a second. And what happens to those earlier pages in the calendar? They are folded, buried, recycled. Continental crust is subducted into the mantle, remelted, resurfaced. Oceans vanish and reform. Entire mountain ranges rise, erode, and crumble to sand. The earth is restless. Surface is a manuscript constantly rewritten, with only a few stubborn words surviving from ancient drafts. Zircon crystals from Western Australia, 4.4 billion years old, are some of the rare exceptions, tiny survivors of a vanished world. If rock itself barely survives, what of civilization? Here the analogy of the ocean deepens. Imagine drifting across the surface of an immense sea. Beneath you lie layers of currents, each moving in its own rhythm. Some are ancient waters, untouched by sunlight for centuries, while others are recent swirls mixing with storms. Time, too, has layers like this. Some epochs preserve detail, the fossilized skeleton of a trilobite, the delicate frond of a fern. Others are currents lost to dissolution, entire ages melted away with almost no trace. Human eyes rarely notice the absences because our vision is so short. If civilizations once existed millions of years ago, they may reside in those missing currents. Their remains would be faint, diluted into the ocean of time, indistinguishable unless we learn to tune ourselves to unusual signals. The deep earth does not remember in words. It remembers in isotopes, in crystalline lattice, in subtle chemical ratios. Even those memories fade with pressure and heat. Our question becomes not whether traces exist, but whether enough survive. To be detectable, the ocean metaphor also reveals the fallacy of straight-line thinking. In rivers, history runs forward. In oceans, currents circle, gyres repeat, upwellings bring ancient waters to the surface. Civilization may not be a singular event, it could be cyclic, appearing when conditions converge, vanishing when disrupted, then arising again. It's just as ocean currents bring old nutrients back into play, the earth may allow intelligence to return, renewed each time by a different lineage. Our own presence could be such a return, a resurfacing of possibility rather, than its first invention. Yet humility is required. While the metaphor of the ocean invites imagination, the data remains sparse. The farther back one looks, the less complete the record becomes. Sediments older than 200 million years on the seafloor are almost entirely gone, drawn beneath tectonic plates. Continental crust preserves more, but only in fragments like islands floating in a restless tide. This bias means that any search for precursors must navigate an ocean full of gaps. The silence of those gaps is not proof of absence. It is simply the sound of time's waves. To think of time as an ocean is to accept mystery as part of the natural order. The deep is not empty, merely veiled. For our species, poised in its fleeting second, the ocean offers perspective. We are not standing at the end of a river. We are adrift on the surface of something immeasurable. Whether or not others drifted here before us, their possibility expands. The horizon. It allows us to see our own moment not as a pinnacle but as one more current, briefly distinct, soon to merge with the larger tide. The question becomes sharper when one asks not whether evidence exists, but what exactly we are looking for. The term civilization carries human way to agriculture, cities, writing, machines. Yet these markers are tuned to our own species. If a different intelligence once flourished, separated from us by millions or hundreds of millions of years, their expression of civilization might not resemble ours at all. To seek them, we must first loosen the definition. At its core, a civilization could be described as a system capable of shaping the planetary environment in durable, detectable ways. It is not merely the presence of intelligence, but the sustained externalization of that intelligence into the fabric of Earth. This might involve industry, metallurgy, or synthetic chemistry. It might also involve large-scale biological engineering or an energy system unfamiliar to us. The key is persistent. Some alteration robust enough to leave behind a trace, distinguishable from natural cycles. This definition sets aside human cultural categories. Cities, for example, are unlikely to fossilize. Even our great metropolises, if abandoned, would vanish into soil and stone within tens of thousands of years, reduced to ghostly imprints. What remains instead are global signals, shifts in atmosphere, chemistry, or geology. One does not necessarily need skyscrapers to qualify as a civilization under this planetary lens. One needs only the ability to inscribe a legible signature. Into the long record of Earth, consider the possibility of a civilization that never discovered metallurgy, but achieved mastery of biochemistry. Such beings might cultivate ecosystems into deliberate patterns, altering the composition of oceans or forests in ways that ripple through the fossil record. Or imagine a society that harnessed energy directly from geothermal gradients, leaving behind networks of tunnels, mineral, precipitates, or heat signatures. These are alien to our expectations, yet they satisfy the broader definition: intelligence, reorganizing matter and energy in ways detectable far beyond its lifetime. This redefinition has consequences. It widens the search, but it also complicates. Natural processes already create many global changes. Oxygenation events, methane releases, extinction pulses all are recorded in the strata. None require civilizations to explain them. To discern an artificial signature, we must look not for singular anomalies, but for unlikely convergences. A sudden spike in metals coinciding with synthetic compounds, an isotope shift paired with unusual fossil absences, patterns too coordinated to be dismissed as chance. Civilization, in this sense, becomes a hypothesis of last resort, invoked when natural causes strain against plausibility. Some may argue this definition dilutes the word, that civilization implies culture, art, thought. Yet those qualities are ephemeral, unlikely to cross the gulf of millions of years. What endures is material impact. Even for us, future geologists will know little of our languages or beliefs. They will know us by plastics, by radionuclides, by carbon isotopes. Our stories will dissolve, but our alterations will remain. So too, if predecessors existed, we would meet them first, not in their myths, but in their chemistry. Here the perspective softens into something more meditative. To define civilization this way is to acknowledge that what matters to us, our songs, our loves, our fears, is not what matters to time. The Earth does not archive meaning. It archives disturbances, residues, shifts in balance. Civilization is redefined not as a self-perceived glory, but as a trace, an inscription written accidentally into stone. This is humbling, but it also invites wonder. It suggests that to seek others is to learn again how small we are within the planet's long memory, and so the search expands. Civilization becomes not a reflection of ourselves, but a question about what kinds of ordered systems the Earth could host. Our task is not to imagine perfect mirrors of humanity, but to imagine what sorts of signatures any intelligence, bound to physics and chemistry, might inevitably leave behind. This requires restraint as well as creativity. Bound to narrow a definition, and we miss them. Too broad, and everything becomes civilization, and the word loses its edge. The balance lies somewhere in the middle, in the careful calibration of what the planet can preserve. When civilization is defined this way, the silence of the record is not yet decisive. It simply tells us we have not looked deeply enough, or asked the right questions of the strata. It whispers that absence and erasure are not the same, and it places us for a moment outside our own frame, able to see ourselves as one possible mode of planetary inscription. Among others that might have come before, there is a horizon past which archaeology cannot reach. Human tools, bones, carvings, and dwellings populate the last tens of thousands of years, faint threads of continuity woven into the earth. Beyond that horizon, the trail dims, then disappears. Fossils persist, yes, but not the layered evidence of organized society. The archaeological record is not an endless path, but a lantern shining only so far into the night. When we ask whether other civilizations could have existed before us, we are asking whether anything remains beyond that faint glow. Archaeology is anchored in visibility. A clay tablet etched with symbols, a foundation of stone, a shard of pottery. These are tangible, mappable, classifiable. But the oldest reliable traces of our kind extend only back a few tens of millennia. Even the earliest symbolic expressions, cave paintings, ornaments, extract carvings, do not reach beyond 100,000 years. Beyond that, the lantern sputters. The record becomes sparse, scattered, less certain. For earlier humans, and certainly for any hypothetical predecessors, the distance is so great that archaeology's tools alone cannot bridge it. Geology takes over where archaeology fails. Rocks become the archive, not sites or artifacts. This shift changes the scale and the texture of the question. We no longer ask, where are the ruins? Rather, what signal might remain in stone or soil? The archaeological horizon is instructive precisely because it illustrates how fragile cultural evidence is. Even in our own deep prehistory, where humans unquestionably existed, the record is fragmentary and contested. How much more so for civilizations that may be millions of years older, whose traces would have endured the abrasion of entire geological epochs. The difficulty is not just erosion. It is also scale. Human archaeology thrives on the excavation of a site, the reconstruction of a settlement. But time on the order of millions of years forces us to search for planetary signals. A shard of pottery cannot persist that long, but a global carbon isotope anomaly might. This shift requires a reorientation of method. Archaeology, as classically practiced, ends at its horizon. What lies beyond belongs to a discipline not yet fully named, a hybrid of geology, geochemistry, and speculative planetary science, even. So, the archaeological horizon remains a useful metaphor. It reminds us that knowledge is bounded, that absence of evidence is shaped by the limits of our methods. Consider how recently the horizon has expanded. The discovery of Göbekli Tepe pushed back monumental architecture by thousands of years. Denisovan DNA, hidden in our genomes, revealed an entire human lineage unseen in the fossil record. Horizons still await beyond the reach of current science. The past is not closed, it is porous. Each discovery pushes the lantern's glow a little farther, and each discovery humbles our confidence in what we thought was settled. The horizon also reminds us of scale mismatch between human and geological memory. What archaeology can resolve is a flicker compared to the planet's depth. 10,000 years is vivid. 1,000,000 years is mist. 50 million years is darkness. When framed this way, the absence of evidence for prior civilizations becomes less surprising. It is not necessarily a verdict. It is the expected consequence of working at the edge of what the Earth can preserve. Here the thought slows, softens. Imagine a desert at night, the stars sharp above. You hold a lamp, its glow illuminating a circle of stones and sand. Beyond the circle is darkness. You cannot say with certainty what lies there, not because it is empty, but because the light has not reached it. Archaeology is that lamp. Geology extends the glow, but even then, the desert is vast. The possibility of forgotten civilizations is hidden not only by erasure, but by distance, by the immensity of time itself. Thus, the archaeological horizon is not a wall, but a reminder. It tells us where our sight currently ends, where questions dissolve into speculation. It invites patience, humility, and creativity. To press beyond it, we must shift disciplines, scale our thinking, and learn to listen to the planet's deeper signals. The whisper of lost civilizations may linger there, just beyond the circle of light. When we search for the remnants of ancient civilizations, we imagine ruins, walls still standing, columns half buried, sculptures worn smooth by time. Yet the truth is far quieter. Stone, bone, and silence make up most of the record. Even in the span of a few thousand years, the world reclaims what is built. Cities vanish under vines, forests grow over temples, bones dissolve into soil. In 10,000 years, only the most stubborn materials persist. In a million, even stone crumbles into grains that no longer remember the hands that shaped them. Bones are among the most fragile. Without rapid burial and sediment, they return quickly to dust. The fossil record is not a continuous archive, but a lottery. Entire species are absent simply because their remains never fossilized. Even among the dinosaurs, whose reign lasted over 100 million years, only a fraction of all species are known. How much less likely, then, is the preservation of delicate human-made objects, soar their equivalents from any other civilization? Pottery shards may endure a few tens of millennia. Metals corrode wood vanishes. It's on scales of tens of millions of years. The odds approach zero. Stone resists longer, but even it is not eternal. Temples carved into cliffs, roads laid across continents, monuments raised toward the sky road. The cycles of freeze and thaw, rain and wind, tectonic uplift and subsidence reduce the most durable structures into rubble and then into sand. Fossilized stromatolites formed by microbes endure billions of years because they are continuously lithified, integrated into rock. But human architecture, even in its grandeur, is only stone placed upon stone, unprotected from entropy. Unless entombed in unusual conditions, its endurance is measured in thousands, not millions of years. Silence, then, becomes the dominant feature of deep time. The silence is not proof of emptiness. It is the expected consequence of erosion, recycling, and loss. What survives tends to be indirect: isotopic shifts, layers of ash, mineral transformations. Civilization's traces, if they exist, would need to be sought in this quieter register, not in bones or walls, but in the subtle fingerprints left on chemistry and geology. The loud signals we imagine, pyramids, machines, tools, are too transient to bridge the gulf. Only whispers survive. Yet whispers can be powerful. Consider how paleontologists reconstruct whole ecosystems from pollen grains, how geochemists trace volcanic eruptions through thin bands of ash, how climatologists read ancient atmospheres trapped in bubbles of ice. If such delicate signals can persist, then the imprints of civilization, though unlikely, are not inconceivable. They would be faint, but detectable, if one learns to listen in the right key. The silence of stone and bone is not absolute. It is a silence punctuated by rare survivals, improbable yet invaluable. Here, imagination bends toward humility. If our cities crumbled tomorrow and 10 million years passed, what would remain? Perhaps a thin stratum of concrete turned to carbonate, flecks of synthetic polymers altered by pressure into novel minerals, trace metals out of balance with natural cycles. No architecture, no libraries, no art, only hints, ambiguous subject to debate. And if this is true for us, it must be true for any who came before. Civilizations may have risen and fallen, leaving behind only subtle shifts buried beneath the patience of stone. Stone, bone, and silence together teach us the fragility of permanence. They remind us that survival in the geological record is the rare exception, not the rule. To ask for direct evidence of ancient civilizations is to ask for a miracle of preservation. To search for indirect signals is to accept the world as it is, a restless surface, ever-changing, reluctant to hold on to memory. Thus the question persists not because evidence is absent, but because silence itself can be ambiguous. The Earth's Quiet is not necessarily emptiness. It is possibility withheld, awaiting interpretation. In the spaces where stone endures, where bone fossilizes, and where silence stretches longest, there may lie the only traces of what once was. If indeed there was anything at all, our present moment carries a strange duality. It feels both immense and fragile. We look upon our cities, our machines, our networks, stretching around the planet, and imagine them as indelible marks of progress. Yet when measured against geological time, they are thin, temporary, perhaps already dissolving. The Anthropocene, the proposed epoch marked by human impact, becomes a lens through which to imagine how future observers, millions of years hence, might judge our presence. And it also becomes a mirror. It shows us how lonely such a mark may appear if no others preceded. The Anthropocene is defined not by monuments or culture, but by planetary signals. Plastics entombed in sediments, radionuclides dispersed from nuclear testing, a sudden spike in greenhouse gases, the accelerated extinction of species. All these are measurable, durable, unlike our stories or our songs. If some intelligence, in a far future, drilled cores through the Earth's crust, they would not uncover Shakespeare or skyscrapers, but rather a thin geochemical anomaly, a layer of altered minerals and disrupted isotopes. Our grandeur contracts into chemistry. This perspective is sobering, reveals how little of us may endure, even at our most expansive. 1,000 years from now, perhaps ruins will remain.
10,000. And those ruins will be dust. 1,000,000.
And nearly everything recognizable will have vanished, save for subtle signals hidden within stone. Our loneliness stems from this realization that even with all our industry, we are a faint line in the deep book of Earth, if we are alone. If no civilizations came before us, then the Anthropocene may be the only line of its kind. But this, loneliness, is not certain. The Anthropocene also provides a benchmark. By examining what our civilization leaves behind, we can imagine what predecessors might have left. Our spike of carbon resembles, in some ways, natural excursions such as the Paleocene thermal maximum. Our synthetic compounds echo novel minerals formed by impacts or volcanism. Distinguishing the human-made from the natural is difficult even for our own signal. How much more ambiguous would the traces of an ancient civilization be layered beneath? Tens of millions of years of overprint. The Anthropocene thus becomes both a case study and a warning. A whisper of analogy emerges. Imagine Earth as a vast palimpsest manuscript, each epoch writing its text upon the faded ink of the last. The Anthropocene is a hurried scrawl in bright ink. To us it feels overwhelming, but in the layered page it may prove just another faint passage, overwritten by future ages. And yet its existence confirms that civilizations can inscribe themselves in detectable ways. If we can do so, perhaps others did too. The loneliness is real, but it is not final. Still, the idea of being the only ones lingers with weight. If no others existed before, then we are solitary in a way that deepens responsibility. Our mark is not one among many, it is unique. Silence of the past would mean that intelligence is a rarity beyond rarity, an event so improbable it has occurred only once in billions of years. Our loneliness would be profound, but it would also heighten the significance of our stewardship. We would not be inheritors of a lineage, but the first to shape the earth in this way. The Anthropocene's loneliness thus oscillates between two possibilities. Either we are alone, and our mark is singular, fragile, and momentous, or we are not alone, and our mark is simply the latest in a sequence of hidden inscriptions. In both cases, the outcome is humbling. So whether solitary or one among many, our presence is fleeting, our permanence uncertain. The Anthropocene whispers not of triumph, but of perspective. It reminds us that every trace, even at planetary scale, is temporary against the ocean of time. If civilizations once rose and fell before ours, then one must reckon with the most tireless destroyer of evidence, the restless skin of the planet itself. Plate tectonics is Earth's quiet, ceaseless eraser. Continents drift like rafts, collide, and fracture. Ocean floors spread, dive, and vanish. Mountains rise only to wear down into plains. Over spans of hundreds of millions of years, nothing at the surface is secure. What feels to us like bedrock is only a page waiting to be turned. Consider the oceans first. The oldest seafloor on Earth is scarcely 200 million years old. Every older stretch has been consumed, subducted into the mantle, remelted into magma. This means that if a civilization had thrived on coastal plains, on seafloor ridges, or upon islands that have since sunk, their entire world could be erased. Without a trace beyond what tiny fragments of continental crust might have captured, to search for signs of ancient civilizations in oceanic rock older than the dinosaurs is futile, for none exists. The planet has wiped that slate clean. On the continents, survival is somewhat better, but not by much. Ancient cratons, the most stable cores of continents, preserve rocks billions of years old. Yet even they bear the scars of metamorphism, folding, and erosion. Sediments compress into stone, then recrystallize, then shatter in weather. Any surface structure, however monumental, would be broken down and scattered long before 100 million years passed. Only indirect signals might remain. Unusual mineral assemblages, chemical shifts frozen in strata, patterns too odd to attribute easily to nature. Plate tectonics does not erase evenly. It creates blind spots and survivals. A volcanic province may entomb evidence in ash, preserving it by accident. A sedimentary basin may accumulate layers gently enough to shield traces from destruction. Conversely, mountain-building events can obliterate vast regions, leaving no hint of what once stood there. Preservation is a lottery, and tectonics is both the dealer and the house. Its bias leans strongly toward erasure. This geological restlessness reframes the question. The lack of direct evidence for prior civilizations is not surprising, it is expected. Even if such civilizations existed, most of their traces would have been subducted, metamorphosed, or eroded away. To demand unambiguous artifacts across tens of millions of years is to misunderstand the nature of the archive. The planet is not a museum. It is a recycling furnace. Endlessly rewriting its own record, one might imagine Earth as a chalkboard in a classroom with no walls. Each generation of geology writes its notes, only for wind, rain, and hands to wipe the board clean again. Now and then, faint residues linger, lines half visible in the right light. But most of what was written is gone. Our search for prior civilizations is a search for these residues, for the subtle palimpsests that escape total erasure, a red team. Argument arises here. If civilizations of scale had existed, shouldn't at least some direct evidence survive? After all, we have fossils hundreds of millions of years old, stromatolites billions of years old. But fossils are rare precisely because the right conditions sealed them. Civilizations may not have been so lucky. Their artifacts may not have fossilized, and their materials may not have been as enduring as microbial mats turned to stone. The absence of ruins, therefore, does not falsify the possibility. It only highlights the ferocity of tectonic erasure too. Hold this thought is to recognize the fragility of permanence. What feels eternal the ground beneath us, the mountains at the horizon, is in truth transient. Our cities, our infrastructures, even the outlines of our continents will be swallowed in time. Plate tectonics assures it. And if others walked here before, their silence is not mysterious, but expected. Their memory may survive only as a chemical anomaly in a rock, a discordant mineral in a seam, a pattern whose meaning we may never decode. Thus, the great eraser humbles us, tells us that Earth is not only old but restless, unwilling to preserve indefinitely. It whispers that if civilizations have risen before, they have been given no sanctuary. They have been folded back into the mantle, transformed into lava, returned to anonymity. To imagine them is to imagine a kind of deep companionship with absence, the awareness that the Earth remembers selectively and often prefers to forget. When humans dig into the Earth for coal, oil, and gas, we are tapping into a record far older than our species. These fuels are the compressed remnants of ancient forests, plankton blooms, and swamps, transfigured by pressure and time into dense reservoirs of energy. In drawing them forth and burning them, we release sunlight captured hundreds of millions of years ago, a deep inheritance stored in stone. Fossil fuels thus act as both resource and mirror, reflecting the vast biological productivity of Earth's past. But could they also reflect something more? Something like the shadow of civilizations before our own? At first glance, fossil fuels suggest abundance, not intelligence. They arise from natural cycles of life and death, accumulation and burial. The great Carboniferous swamps gave us coal seams. The Mesozoic oceans enriched oil shales. No civilization is needed to explain them. And yet when we consider our own time, we notice a parallel. Our combustion of these fuels inscribes a signal into the atmosphere, a rapid carbon isotope excursion, a chemical fingerprint that future geologists could detect. In this sense, fossil fuels reveal a recursive loop. Ancient biomass becomes fuel. Fuel becomes signal. Signal becomes future fossil record. If earlier civilizations had also harnessed buried energy, they too might have left comparable isotopic anomalies. The difference would be scale. Natural events such as massive volcanism can also drive carbon excursions, as in the Permian extinction. To disentangle civilization from nature, one would need more than a single signal. One would need coordination. Isotope anomaly coinciding with other markers, unusual metal distributions, synthetic compounds or abrupt biotic patterns inconsistent with volcanism alone. Fossil fuels become not evidence in themselves, but a clue to what kind of evidence we should seek. Here lies a paradox. Fossil fuels are both enabler and eraser of civilizations. By burning them, we inscribe our presence into geology. Fuels themselves arise only in specific windows of history, when conditions for organic burial align. If another civilization arose millions of years ago, did it have access to such reservoirs? Perhaps not, if it appeared before major coal formation, or after certain deposits were exhausted. This dependency highlights the contingency of our own trajectory. Our path is not inevitable but tied to the peculiarities of Earth's carbon archive. An image emerges. The planet as a long memory of sunlight folded into seams and reservoirs awaiting rediscovery. We mine this memory, burn it, and in doing so write our own line into Earth's future memory. The cycle feels almost poetic, a dialogue across time, ancient forests fueling modern industry, altering future stone. If others once did the same, their dialogue has been erased, folded into the general chorus of carbon shifts, indistinguishable, unless accompanied by other voices in the rock. Preservation bias deepens the uncertainty. Oil fields migrate, reservoirs leak, seams erode. Even if another civilization had burned fossil fuels, the residues might blend with natural signals, indistinct to our eyes. What we interpret as volcanism could be partly industrial. What we see as natural carbon flux could carry an artificial undertone. Without multiple converging lines of evidence, the distinction collapses. Fossil fuels are mirrors, but they are cloudy ones. Still, the mirror teaches humility. It shows us that the Earth has cycles larger than us, that our civilization is not. The first to interact with stored carbon, though perhaps the first to do so knowingly. It also shows us how our presence will be judged in deep time, not by our monuments, but by our chemistry. Whether or not predecessors existed, the burning of fossil fuels ensures that we are already woven into the geological archive inscribed in the isotopes and residues that future eyes may one day study. Thus, fossil fuels do not prove or disprove ancient civilizations. Instead, they sharpen the question, demonstrate how energy use leaves durable, if ambiguous, traces. They remind us that civilization at its most planetary scale becomes indistinguishable from geology. And they whisper that if others once were here, their signatures may lie hidden among the very fuels we now consume, their traces burned again in our own fires. If ancient civilizations left traces, the sediments of Earth would be among the most likely places to find them. Layer by layer, rivers deposit silt, oceans lay down mud, winds scatter dust across plains and lakes. Over millions of years, these thin sheets of matter compress into stone, each one a quiet page in the planet's archive. The challenge is learning to read this script, which is written not in words but in ratios, anomalies, and unexpected concentrations. Sediments are soft-spoken storytellers. Their voices must be coaxed out with patience. What kinds of signals might we expect? One is isotopic, changes in the ratios of carbon, oxygen, or nitrogen that cannot easily be explained by natural cycles. Human industry, for example, is already driving a rapid decline in the ratio of heavy to light carbon isotopes, C, as fossil fuel burning releases light carbon into the atmosphere. Future geologists could detect this excursion, distinguishing it from natural variations by its abrupt onset and speed. If earlier civilizations had burned carbon on a large scale, they too might have left a comparable fingerprint. Another possible signal is elemental. Industrial activity redistributes metals, lead, chromium, mercury, rare earth elements, into concentrations and contexts rarely produced by nature. Our coal burning alone has spread measurable traces of mercury across continents. Our electronics scatter rare metals across landfills. If similar anomalies were found in sediments millions of years old, layered alongside other markers, they might whisper of technological activity. Synthetic compounds offer a further category. Plastics, pesticides, and other complex molecules do not arise spontaneously in nature. Their persistence is uncertain. Most would degrade under pressure and heat, but some might transform into novel minerals or unusual carbon structures. If discovered in ancient sediments, such materials could be strong evidence of non-natural processes. Yet here lies the confounder. Extraordinary natural events can also produce unfamiliar compounds. Lightning fuses sand into glass. Asteroid impacts create shocked minerals. Distinguishing the artificial from the extraordinary is the delicate work of interpretation. Sediments also capture abrupt absences, sudden declines in fossil pollen, microfossils, or fauna that may reflect mass extinctions. Civilization could induce such disruptions as our own activities are now doing. But extinctions, too, have many natural causes: volcanism, impacts, climate swings. The evidence ladder demands convergence, only when isotopic anomalies, elemental spikes, synthetic compounds, and biotic disruptions appear together does the case grow persuasive. One signal alone is not enough. Preservation bias complicates everything. Sediments are most complete in calm basins, lakes, and continental margins. Elsewhere, they are eroded, reworked, or destroyed. The farther back we look, the more discontinuous the record becomes. Finding a signal of civilization is thus not merely about detection, but about extraordinary luck and preservation. The chance alignment of activity, deposition, and protection must occur for millions of years to deliver even a whisper of evidence. But to us today, yet the possibility remains alluring. Imagine drilling a deep core from Antarctic ice or an ancient ocean basin, pulling up cylinders of stone marked with subtle bands. Each band is a season, a storm, a volcanic eruption, a shift in chemistry. Most are natural, but perhaps one layer shows an anomaly. A cluster of metals in ratios inconsistent with volcanism, paired with an abrupt carbon shift in a novel compound. The pattern would not prove a civilization, but it would raise the question, opening a new space of inquiry. Sediments invite us to think of time as stratified, each layer a pause in the planet's breathing. To search them for civilizations is to search for discordant notes in the harmony of cycles. It is patient work, humbling work, with no guarantee of success. But it is also the most plausible place where such whispers could reside. If any record remains, it is likely herein the fine dust of vanished seas, pressed into stone. Waiting when searching for traces of possible ancient civilizations, one must always contend with nature's own repertoire of signals. The Earth is inventive, capable of producing anomalies that resemble artificial signatures. A spike in carbon isotopes could reflect combustion of fossil fuels, or it could arise from massive volcanism, methane release, or asteroid impacts. Concentrations of metals might suggest industrial activity, but they could just as easily be the fallout of eruptions or the residue of hydrothermal vents. Natural imitators stand everywhere in the record, masquerading as potential evidence. To distinguish them from true civilization requires careful discrimination. Consider the end Permian extinction, 252 million years ago. The strata from that time reveal an immense carbon isotope excursion, widespread anoxia, and pulses of toxic metals. Some features echo what our own industrial activity is producing. Yet the cause was natural: vast Siberian volcanism releasing greenhouse gases, destabilizing ecosystems, and leaving behind a catastrophic signature in stone. If this were our only evidence, one might mistake it for an industrial fingerprint. Nature, in this case, already wrote the signal without intelligence. Asteroid impacts are another great imitator. The Chicxulub impact, which ended the age of the dinosaurs, scattered iridium-rich dust across the globe, produced shocked quartz, and left a thin layer marking the transition between eras. Such a layer could be read as deliberate metallurgy, or rare material Yusuf I did not know its origin. The precision of the marker, its global presence, and its abruptness might all invite misinterpretation. Nature, once again, produces dramatic anomalies that could masquerade as civilization. Even more subtle are hydrothermal systems. These can concentrate metals, create unusual mineral assemblages, and deposit chemical signals that, to a casual reading, might seem artificial. Deep-sea vents, with their towers of sulfides and rare elements, show how chemistry can mimic industry. Lightning strikes, too, fuse sand into glass. Forest fires alter carbon balances. Earth's creativity is broad, and it has had billions of years to practice. This proliferation of natural imitators is not discouraging. It is clarifying. It sharpens the criteria by which we evaluate evidence. A single anomaly, however strange, is insufficient. One must seek convergence, multiple signals, co-occurring in patterns that natural processes cannot easily produce. For example, a carbon excursion paired with synthetic compounds and unusual isotopic ratios in metals would be difficult to explain volcanically. The probability of natural imitation decreases as signals align. Civilization, if it leaves a detectable footprint, would reveal itself in the improbability of such convergence. The presence of natural imitators also serves as a red team argument. It forces humility. Our own Anthropocene layer, if viewed millions of years hence, might be mistaken for a volcanic event were it not for plastics, radionuclides, and coordinated global metal shifts. In this way, studying imitators helps us imagine how our signal might be misread, and how we might misread any predecessors. Nature reminds us that appearances deceive, that extraordinary claims demand extraordinary discrimination. An image comes to mind. Earth as an artist working in abstract strokes, filling the canvas with explosions of color and form. Some strokes resemble deliberate patterns, others appear random, but all are natural expressions of geology and biology. Amid such a canvas, discerning whether a particular stroke was drawn by intelligence is profoundly difficult. The imitators blend with the possible originals, and certainty becomes elusive. And yet, it is in this ambiguity that science breathes. The difficulty is not failure, but invitation. It drives us to refine detection, to broaden context, to seek corroboration. It reminds us that nature's inventiveness is vast, and that our interpretations must always respect its primacy. Only when patterns rise beyond imitation, converging across disciplines, may we begin to whisper of civilization's past. Until then, natural imitators fill the silence, teaching us patience, skepticism, and wonder. Beneath the rolling oceans lies a realm that seems eternal. Yet it is among the most transient surfaces on Earth. The seafloor, dark and cold, receives the steady rain of sediments, dust, shells, the quiet residue of life drifting downward. It appears to be a perfect archive, an immense library accumulating record after record of planetary history. But the silence is deceptive. Oceanic crust is constantly reborn at mid-ocean ridges and consumed at subduction zones. None of it survives for more than about 200 million years. Against Earth's 4.5 billion years, this is a mere breath. The seafloor forgets quickly. If a civilization had flourished upon islands or continental shelves hundreds of millions of years ago, traces would now be gone. Even entire continents, like Zealandia, can sink beneath the sea, their stories drowned and recycled into mantle. The deep basins where sediments might preserve delicate signals are themselves impermanent. Erased when plates shift and ocean crust is dragged downward, the ocean floor is like a chalkboard wiped clean and rewritten every few pages. A surface unable to hold memory beyond a brief interval. This forgetting shapes our search. We cannot hope to find traces of civilizations older than the oldest surviving. Seafloor. If they existed, their worlds are now molten, reincorporated into magma, their signatures blurred into chemical noise. Only fragments might escape, sediments scraped off onto continental margins, microfossils carried into younger basins. The ocean swallows most of what it is given. Its silence is thorough, yet the sea does leave some whispering remnants. Drilled cores from the ocean floor reveal detailed histories of the last 100 million years, shifts in climate, pulses of extinction, sudden depositions of iridium or ash. These records are fine-grained, season by season in some cases, and they teach us how powerful ocean sediments can be as archives while they last. If a civilization arose in the last few 100 million years, its traces could, in principle, be visible in such cores. But the window is narrow, and the silence beyond is absolute. Confounders again complicate matters. Ocean sediments capture extraordinary natural events and oxic episodes. Methane hydrates collapsing, volcanic ash drifting for thousands of kilometers. These appear as anomalies that could be mistaken for industrial signals. Distinguishing natural disruption from artificial requires comparing patterns across basins, seeking the improbable convergence of signals not otherwise explained. The sea's records are rich, but they are also cryptic. The silence of the seafloor reminds us of scale. Human time imagines oceans as eternal. Geological time shows them as temporary. The continents are the true keepers of the oldest memories, for only they resist subduction long enough to bear witness to the earliest epochs. If civilizations existed far back in time, their stories must be sought in continental sediments. In the most ancient cratons, not in the oceans constantly. Erased canvas. And yet, the metaphor of the ocean is poignant. Imagine an immense library whose books are burned every 200 million years. Rewritten anew, their ashes scattered into the tide. Only stray fragments remain, pasted into younger volumes, their original context lost. The silence we encounter, when probing deeper than that, is not necessarily emptiness, it is erasure. Civilization may have existed, but the ocean, patient and tireless, has chosen not to remember. The lesson is quiet but profound. Not all absences are alike. Some are absences of never having been. Others are absences of forgetting, of erasure. The seafloor embodies the latter. Its silence is a choice made by geology, a consequence of planetary restlessness. When we search for predecessors, we must always hold this in mind. To demand proof from the oceans beyond their memory is to ask a library for books it has already. Consumed, the sea remembers briefly, then moves on. The earth is not a uniform archivist. Some regions preserve memory with unusual care, while others erase it almost as soon as it is made. Deserts of evidence stretch across time and geography, creating vast blind spots in our search for civilizations past. These are not barren of life or history, they are barren of preservation. The unevenness of Earth's record means that silence cannot be read simply as absence. It may only be the shadow cast by erasure. Consider the tropics. Heat, humidity, and abundant life accelerate decay. Organic material breaks down swiftly. Bones and wood vanish into soil. Stone is overtaken by vegetation and weather.
Archaeological.
Work in rainforests today demonstrates how quickly traces dissolve. Entire cities can disappear beneath the canopy within centuries, leaving only faint mounds and altered soils. Scale this forward to millions of years, and the tropics become black holes of preservation. If an ancient civilization thrived there, little would remain for us to find. Floodplains and river deltas pose another challenge. They are cradles of life and culture, fertile and abundant, but they are also restless. Rivers shift their channels, burying and re-exposing sediments, grinding evidence into sand. Floods scour surfaces. New deposits overwrite the old. The record here is fragmentary, a palimpsest of alternating preservation and destruction. A civilization born along rivers might be erased almost as soon as it vanished. Mountainous regions fare no better. Erosion is relentless, carrying stone downslope to the sea. Uplift exposes ancient layers, but also tears them apart. Even where fossils survive, they are scattered, broken, incomplete. If monumental structures once stood upon ancient highlands, their remnants may now lie as grains in distant basins, unrecognizable as works of intelligence. By contrast, deserts of sand can preserve with surprising fidelity, but only briefly. A city entombed in dunes may survive for thousands of years, even tens of thousands. Yet sand shifts, winds, scour, and eventually erosion dismantles all. Over millions of years, the desert too becomes an eraser. The preservation we sometimes glimpse in arid lands is temporary, not eternal. This patchiness of evidence creates a profound asymmetry. Our imagination seeks global certainty. Either there were civilizations, or there were not. But Earth's record resists such clarity. It offers glimpses here and there, never a complete picture. Even well-documented epochs, such as the age of dinosaurs, are riddled with gaps. Entire lineages remain unknown, entire ecosystems invisible. If biological histories are this incomplete, how much more so the fleeting signals of intelligence? Bias, then, is not merely a technical detail. It is the central obstacle. The deserts of evidence remind us that silence may simply mean the right conditions never aligned. No rapid burial, no protection from erosion, no fortunate lithification. The difference between a preserved fossil and total erasure can be the width of a river channel, the timing of a landslide, the chance fall of ash. Civilization, no matter how advanced, is subject to this same lottery. The thought is sobering, but also expansive. It tells us that our inability to find proof does not settle the question. It tells us that even if others came before, their traces may be lost beyond recall. And it reminds us that our own legacy is equally contingent. Our buildings, our artifacts, our very species depend on geological chance for survival. Against the deserts of evidence, even the Anthropocene may one day seem like a whisper carried off by wind. An image forms, Earth as a patchwork quilt. Some squares thick with stitching, others threadbare, others missing altogether. We study the quilt as though it were whole, but what survives is uneven. The deserts of evidence are the blank spaces in the pattern, the lacune, where memory falters. To ask whether civilizations came before is to stare into those gaps, knowing that what is missing may never return, yet refusing to mistake absence for certainty. Imagine, gently, that there was once a civilization before us, small in scale, brief in duration, and fragile in footprint. Perhaps it arose in a warm interlude between ice ages, or during a stable epoch of climate tens of millions of years ago. Perhaps it spanned only a continent, never reaching global distribution. Its knowledge, its art, its cities, whatever forms they took, might have flourished for tens of thousands of years, then waned, undone by catastrophe, climate, or its own fragility. A brief predecessor, leaving behind almost nothing. What would such a civilization inscribe upon the planet? Likely less than we have already written in a mere 2 centuries of industry. Its signal might be modest, a localized increase in metal use, some disturbed ecosystems, a faint carbon anomaly. If it never exploited fossil fuels on a global scale, Its chemical footprint could be subtle, indistinguishable from natural variations. The chance that such a signal would survive across millions of years would be slim. Even if it endured, it might be buried under ambiguity. It's dismissed as noise. Preservation bias works especially strongly against a brief predecessor. Without the scale to leave global markers, it would depend entirely on local archives, river sediments, lake beds, or volcanic ash. But these archives are fragile, easily lost. Unless we were extraordinarily lucky, its traces would vanish, its presence collapsing into silence. The archaeological horizon we rely upon would never reach far enough to glimpse it. And yet, the possibility feels neither absurd nor extravagant. If intelligence is a potential outcome of evolution, then why? Should it emerge only once, and precisely now? Life has cycled through countless experiments. Dinosaurs thrived for over 100 million years, mammals for 200 million. Within those spans, it is conceivable that intelligence might have briefly flared, creating a civilization that lasted for a geological instant before fading. Its memory would be erased almost completely, except perhaps for a discordant note in a core sample. A hint awaiting reinterpretation. A red team critique arises quickly. If such a predecessor left no clear trace, the hypothesis is unfalsifiable. It risks becoming metaphysics, not science. But that critique itself is valuable, for it defines the limits of what we can responsibly claim. Scenario A is not a proposal of certainty. It is a thought experiment. It highlights the fragility of civilization's footprint and the plausibility that others might have risen without leaving us anything decisive. The implications, if true, are gentle but profound. We would not be the first to step into awareness, and then into silence. Our existence would be part of a lineage of experiments, most of which fail or fade without echo. The Earth then would not be a solitary stage awaiting its one performance, but a rehearsal space where consciousness arises again and again, briefly illuminated, then gone. The analogy is quiet. Imagine fireflies over a dark meadow. Each glows for a moment, then disappears. From a distance, the meadow seems empty, till one realizes that countless glows have already come and gone, their light erased by time. A brief predecessor would be such a glow, invisible to us now, yet real in its moment. Whether or not this scenario is true cannot be settled. But entertaining, it enlarges the horizon of thought. It reminds us that civilization need not be singular, nor eternal, nor indelible. It may be fragile, contingent, and vanishingly brief like ours may yet be. Now imagine a different possibility. Not a fleeting culture hidden in one corner of the world, but a civilization that grew large enough to leave a planetary mark. Global ancestor. Perhaps it spread across continents, harnessed abundant energy, and altered ecosystems in ways both deliberate and inadvertent. Its works might have been vast, its duration long millions of years, even long enough to reshape landscapes and redirect the course of evolution. If such a civilization once existed, what would remain of it now? The first answer is scale. Global civilization would almost certainly leave geochemical signatures detectable far into the future. Our own Anthropocene illustrates this clearly. Plastics, radionuclides, massive carbon excursions, heavy metal contamination. If a predecessor had achieved anything similar, their signals could still linger as anomalies in the record. They might appear as strange isotopic excursions, unmatched by known volcanic events, or as unusual concentrations of metals and minerals that resist easy natural explanation. The very vastness of their activity could paradoxically make them easier to detect, and yet paradox deepens. The older the civilization, the more time geology has had to erode its evidence. A signal strong enough to last tens of millions of years must be robust indeed. Even global anomalies like those marking mass extinctions can be difficult to parse. The Paleocene thermal maximum, for instance, shows a sharp carbon isotope shift reminiscent of industrial emissions, but prevailing consensus attributes it to massive natural methane release. If a civilization caused it, their signal has become indistinguishable from Earth's own turbulent creativity. Preservation bias again plays its part. Global signals may survive better than local ones, but interpretation remains uncertain. A layer of radionuclides, if discovered, would be strong evidence, but radionuclides decay, and many with short half-lives would be gone within millions of years. Plastics may degrade into new forms of carbon, metals may diffuse. Even a global civilization might, given enough time, dissolve into ambiguity. The persistence of its signature would depend not only on scale, but on the luck of which archives endured. Still, the thought of a global ancestor reshapes perspective. It suggests that our present moment might not be the first time Earth has entered an Anthropocene-like state. Perhaps other civilizations have triggered extinctions, altered climates, or redistributed elements, only to vanish. The silence we perceive today could be the aftermath of such vanishings, their signals blurred into the background hum of geological processes. Critics would ask, where are the fossils? Where are the artifacts? If a global civilization thrived, shouldn't at least fragments survive? This is a strong red team point. Yet one must recall that fossils are rare, artifacts rarer still, and the scale of erasure immense. Even for our own global civilization, what survives after tens of millions of years may be ambiguous at best. The absence of fossils is not proof of absence. It is the expected consequence of deep time. The implications, if true, are profound but not dramatic. Humanity would be one in a sequence of global experiments, not the first to inscribe itself on planetary scales. Our uniqueness would soften into kinship with unknown predecessors. Our Anthropocene would be a chapter, not a prologue. Civilization, in this view, becomes a recurring possibility, rare, but not singular. An image forms, Earth as a coastline after high tide. Each wave washes up debris, arranges it in patterns, then withdraws. Later waves do the same, erasing some traces, leaving others faintly visible. To stand on the shore now is to see only the most recent arrangement, unaware of the countless patterns already washed away. A global ancestor, if it existed, would be one such tide, powerful in its time, subtle in its remains. Thus, Scenario B expands the horizon further. It allows for the possibility that civilizations can be planetary, enduring, and yet still fall. Silent under the weight of time. Their echoes might survive, but faintly, waiting for us to ask the right questions of the strata. There is yet another way to hold the question not as a singular yes or no, not as a choice between absence and presence, but as a rhythm. What if civilization is not an event, but a cycle? What if intelligence emerges, flourishes, collapses, and then emerges again across millions of years, each cycle faintly echoing the last, each leaving traces that fade into ambiguity? In this view, Earth is not host to a single experiment, but to many, each obscured by the others, erased by time, yet part of a larger pattern. The idea of cyclic emergence is speculative, but it draws strength from analogy. Life itself is cyclical. Ecosystems collapse and regrow. Species vanish and diversify. Climates oscillate between warm and cold. Geological time is punctuated by mass extinctions, each followed by radiations of new forms. If evolution can cycle, why not civilization? Intelligence may be improbable, but not singularly so. Given enough time, the dice may be rolled again and again. Success brief but transformative. What would such cycles look like in the record? Perhaps a repeating pattern of anomalies, carbon excursions, extinctions, odd mineral concentrations, EHE, mineral concentrations, spaced tens of millions of years apart, each reminiscent of the Anthropocene, but attributed to different natural causes. We already see such repetitions: the End-Permian, the End-Cretaceous, the Paleocene thermal maximum. Each is natural by consensus, but the resemblance to anthropogenic patterns is striking. If cycles of civilization existed, they would blend into this rhythm, masked as nature's turbulence. The difficulty, again, is discrimination. Natural imitators abound, and evidence weakens with time. To claim cyclic civilizations, one would need to detect more than coincidence. One would need to see non-random alignments, anomalies repeating with structure. separated by intervals too regular to be natural, containing signatures too precise to be geological accidents. The search then becomes statistical as much as chemical, looking for unlikely order in the apparent chaos of history. Preservation bias complicates the vision. Each cycle would be partly erased by tectonics, erosion, and burial. Earlier cycles would be more obscured than later ones, their signals overlapping like faint palimpsests on a reused manuscript. By the third or fourth iteration, traces might be indistinguishable. The record would not show a clear ladder of civilizations, but a haze of anomalies, each interpretable as natural. But together whispering of something more. An implication of cyclic emergence is humbling. If civilizations come and go, ours is not unique in kind and in time. Our rise may be one among many, no more permanent than the others. This does not diminish its meaning, rather it situates it in a larger rhythm. Civilization becomes less a pinnacle and more a tide, one that rises, falls, and rises again. To imagine this is to loosen the hold of linear history, to see ourselves not as final but as recurrent. A quiet analogy. Think of a forest after fire. The flames erase, leaving blackened soil. But soon shoots appear, trees return, and the forest flourishes again. Fire is destructive, yet it also clears the way for renewal. Civilization, too, may be like this. It may burn out, vanish, and then regrow in new forms, guided by life's resilience and time's vast patience. From a distance, one would see not permanence, but pulse. Critics would note that no clear cyclic signal has been found, and that the resemblance of extinctions to anthropogenic patterns is coincidental. This is a valid caution. But the possibility remains a useful thought, a way of imagining how intelligence might not be unique to now. Even if the evidence never surfaces, the vision broadens our sense of what Earth could host. It transforms solitude into rhythm, loneliness into recurrence. If civilizations are cyclic, then we are both alone and not alone. Alone because no predecessors remain to speak with us. It's not alone because others may have risen before and others may rise again after. Our presence becomes a verse in a repeating song, faint and fleeting, yet part of a melody as old as the planet. If one had to choose a single thread to follow in the search for forgotten civilizations, carbon would be a natural candidate. Is the backbone of life, the currency of energy, the element that cycles through atmosphere, ocean, and rock. When disturbed, it leaves subtle fingerprint shifts in isotope ratios, anomalies in concentration, patterns that endure in stone long after bones and buildings are gone. Our own industrial age is already altering carbon in ways future geologists will detect easily. If another civilization once burned carbon at scale, its echo may remain as a quiet variation in the isotopic record. The key lies in the ratio of carbon-12 to carbon-13. Fossil fuels are depleted in carbon-13. Drives a measurable decline in C values. This Swiss effect is one of the strongest geochemical markers of our time. Future scientists, millions of years hence, will see it as a sharp, abrupt shift, unlike slower natural cycles. Could similar shifts in ancient rocks point to predecessors? Several events in Earth's history already display striking carbon isotope excursions. The Paleocene-Eocene thermal maximal, for instance, saw a rapid negative C anomaly, global warming, and ecological disruption. It resembles, in some respects, our own Anthropocene. The prevailing explanation is natural massive methane release from clathrates or volcanism. Yet the resemblance to industrial combustion is uncanny. Could such events mask in ancient civilizations? Footprint. Perhaps, though, one must weigh probabilities. Natural sources are well documented and can account for the magnitudes observed. Civilization is not required to explain them. Still, the possibility lingers. What if some anomalies hold layers of meaning we have not yet discerned? Detection demands convergence. A carbon isotope excursion alone is not sufficient. One must look for accompanying signals, metal enrichments, synthetic compounds, unusual sediment structures. If these align, the case strengthens. Otherwise, Carbon remains an ambiguous witness, an ambiguous witness quint. Preservation bias also plays a role. Carbonate rocks record isotopic shifts well, but metamorphism can blur the signature. The deeper in time we look, the less clear the record becomes until only faint hints remain. An analogy may help. Carbon is like ink in Earth's diary. Natural events spill the ink off in volcanoes, impacts, biological revolutions. But civilization spills ink in a different rhythm. Sudden, global, tied to combustion. The challenge is distinguishing handwriting from spatter. Some pages are smudged, others torn, others rewritten entirely. To read the diary well is to resist jumping to conclusions, yet also to remain open to what the ink might whisper. If a predecessor civilization burned carbon, its signal may already be catalogued under natural anomalies. It may sit within geological textbooks as a volcanic event, unrecognized for what it was. Or perhaps their scale was smaller, their signal drowned in noise. In either case, carbon's subtle fingerprints remind us that, even if civilizations leave traces, those traces may be ambiguous. Forever entangled with Earth's own creativity, the implication, if true, is haunting. It means we could already be holding evidence of forgotten civilizations in our hands, but reading it in the wrong language. It means that certainty may never come, only probability, only whispers. And yet that whisper is enough to expand our imagination. Carbon teaches us that memory does not need monuments. Sometimes it resides in ratios, in the quiet balance of isotopes, waiting for someone to notice the tilt. Beneath the soil and stone, deep within strata, laid down long before humans walked upright, metals lie scattered in subtle concentrations. Most are natural iron from ancient seas, copper from volcanic vents, gold from the slow movements of hydrothermal fluids. Yet industry, even at its earliest stages, alters these patterns. It redistributes metals, mines them, smelts them, discards residues that can persist long after the tools themselves are gone. For this reason, the deep layers of Earth are worth considering as potential repositories of anomalous signals markers that might hint at a civilization lost to time. Our own activities illustrate this clearly. Lead pollution from Roman smelting is still measurable in Greenland ice cores. Modern industry has spread mercury, cadmium, and chromium across continents. Rare earth elements, once concentrated only in specific geological contexts, are now dispersed widely in soils and sediments. If another civilization engaged in metallurgy, its presence could be inferred not from artifacts themselves, but from the odd fingerprint of metals redistributed, where they do not belong. The detection signal is straightforward: unusual enrichment of certain elements in sediments or rock layers, inconsistent with local geology and extending across broad regions. Such enrichment, if widespread, could be difficult to explain as natural, yet confounders abound. Volcanism releases metals in abundance. Asteroid impacts scatter iridium and platinum. Hydrothermal activity can concentrate even rare elements. To distinguish civilization from nature, one would again need convergence. Multiple metals out of place, coupled with other anomalies, such as isotope excursions or synthetic compounds. Preservation bias complicates the picture. Industrial residues are often diffuse, scattered thinly across landscapes, vulnerable to erosion. Only under special conditions, rapid burial, low oxygen, stable sedimentation do such residues persist long enough to enter the deep record. Even then, they may be altered by chemical processes, diffused or reabsorbed into mineral cycles. A faint enrichment of lead or mercury in a layer tens of millions of years old could be evidence of industry or simply a volcanic degassing, yet the possibility remains. Imagine drilling into an ancient shale, pulling up cores from 70 million years ago, finding concentrations of metals in ratios that defy natural explanation. Chromium paired with lanthanides. Mercury spikes without corresponding volcanic ash. One could dismiss it as coincidence, or one could wonder whether a hand once moved these elements, shaping them into tools, releasing them into the air. The ambiguity is real, but so too is the potential for discovery. A red team argument insists if global civilizations once existed, we should find unmistakable anomalies in multiple locations. Local enrichments are too easily explained. The counter is that time is a great diluter. Signals disperse, records are patchy, and even global events often appear in the geological record as thin, scattered traces. The search is not for certainty, but for hints, clues that, when aligned, suggest something more than chance. The analogy is gentle. Think of a painter's brush rinsed in water, leaving faint swirls of color. If one looked only at a single droplet, it would seem unremarkable. But if one studied the whole bowl, the patterns might reveal the palette used. Metals in the deep layers are like this faint swirls in Earth's sedimentary waters. Alone they prove little, but together they may speak. The implication is not dramatic. Even if such anomalies were found, they would not immediately confirm ancient civilizations. But they would invite a rethinking of assumptions, a widening of interpretive frames. Metals, more than stone or bone, may be the quiet archivists of past industry. If civilizations came before, their memory might survive less in ruins than in ratios, silent, enduring, waiting for us in the deep layers. Among the most intriguing possible signals of prior civilizations are mineral substances, stable enough to persist for millions, even billions of years. Most minerals form naturally through the slow alchemy of pressure, temperature, and chemical reaction. Yet human activity has already created hundreds of novel minerals, assemblages that would not have occurred without industry. These include alloys, synthetic crystals, and compounds arising from combustion, mining, and chemical manufacturing. Some have been cataloged formally in mineralogical databases as distinctly anthropogenic. In the far future, they will endure as silent witnesses to our presence. The thought is simple, yet profound. If such artificial minerals can survive for geologic spans, then their discovery in deep strata could signal the existence of ancient civilizations. Plastics may degrade, metals may corrode, isotopes may disperse, but minerals, if stable, can persist. They are nature's own archivists, crystalline testaments that endure long after softer evidence is gone. A mineral that should not exist, appearing in a layer tens of millions of years old, would raise immediate questions. Baseline science offers examples. Synthetic compounds like portlandite from cement hydration, novel metallic alloys, and halide crystals produced by industrial processes have no clear natural analogs. They are products of human industry. If we vanished, many would survive, becoming indistinguishable from natural minerals unless their contexts were examined. Geologists of the distant future might puzzle over their sudden appearance in the Anthropocene. By analogy, our own discovery of a similarly inexplicable mineral in older rocks could serve as a strong technosignature, but confounders persist. Nature, too, creates oddities. Lightning forms fulgurites. Impacts produce shocked quartz. Volcanism yields exotic silicates. Hydrothermal systems generate rare alloys under unusual conditions. A single anomalous mineral is not enough. What would count as pattern on assemblage of multiple, clearly non-natural minerals appearing together, especially in a narrow time band across multiple sites? Such convergence would be difficult to explain without invoking intelligence. Preservation. Bias offers both hope and caution. Minerals are among the best preserved traces, but only if stable under new conditions. Some dissolve, others recrystallize, others transform. The deeper in time, the greater the chance of alteration. A technosignature. Mineral might survive, but not always in recognizable form. Its persistence would depend on luck burial in protective settings, avoidance of metamorphism, endurance against groundwater and erosion. The image arises of a mineral as a time capsule, contains no story, no artifact, only structure, atoms, arranged in a pattern unlikely to occur without intervention. Found out of place, it becomes a whisper of something deliberate. Imagine unearthing a crystal lattice aligned with industrial alloys embedded in strata 50 million years old. The discovery would be quiet yet revolutionary, a trace of hands no longer here, inscribed in the lattice of stone, yet a red team note. Tempers the thought. Extraordinary claims require extraordinary clarity. One anomalous mineral could spark debate but not consensus. Only widespread repeated discoveries could compel acceptance. The search, then, is not for single curiosities, but for systemic oddities, a consistent mineralogical shadow of civilization. The implication is modest, but haunting. If civilizations preceded us, their ruins may be lost, their tools dissolved, their stories erased. But their minerals, simple, stable, crystalline, may remain. The earth itself would carry them forward, embedded in layers of time awaiting discovery. Civilization, in this sense, becomes less a maker of monuments than a maker of minerals, writing its existence not in stone carvings but in stone itself. The deeper one looks into Earth's record, the more apparent it becomes that nature itself is restless, endlessly inventive, incapable of producing signals that mimic those of civilization. This confounding pulse complicates the search for predecessors. Every anomaly that might be read as artificial, a carbon excursion, a metal spike, an unfamiliar mineral, has a counterpart born of volcanic fire, asteroid impact, or oceanic upheaval. To see clearly, one must learn to separate rhythm from noise. But the rhythms of nature are themselves unpredictable. Sometimes violent, sometimes slow, always creative. Volcanoes, for instance, scatter their signatures across the globe. They release carbon dioxide, trace metals, and ash that settles into sediment. Their pulses can cause warming, extinctions, and isotopic excursions that last millions of years. The Siberian Traps eruption at the end of the Permian was such an event, releasing enough greenhouse gases to alter climate catastrophically. The geological footprint, it left carbon anomalies, mercury spikes. Disrupted ecosystems resembles in many respects what an industrial civilization might produce. Volcanism is one of the strongest imitators, its signal written boldly in stone. Asteroid impacts, too, are deceptive. They can spread exotic elements globally, generate shocked minerals, and create abrupt boundaries in the fossil record. The Chicxulub impact left a thin layer rich in iridium, marking the Cretaceous-Paleogene boundary, to future eyes, without knowledge of impacts. Such a layer might look like sudden industrial enrichment. Impacts also cause extinctions, which could be mistaken for anthropogenic disruption. The pulse of a collision can appear almost indistinguishable from the footprint of civilization, save for its abruptness. Even biology creates confounders. Cyanobacteria once transformed Earth's atmosphere, producing the Great Oxidation Event more than 2 billion years ago. Their activity left a planetary signature-banded iron formations, a rise in oxygen, shifts in sulfur isotopes that might otherwise be read as the deliberate work of intelligence. Similarly, massive algal blooms or microbial innovations can restructure ecosystems in ways geologists record as anomalies. Life itself, evolving without intent, inscribes signatures rivaling those of industry. This abundance of natural pulses suggests caution. A signal that seems anomalous may simply be another verse in Earth's long creative song. To mistake nature's rhythms for civilization is a real risk. But the inverse risk also exists, dismissing a genuine signature because it resembles nature too closely. Between these two errors lies the delicate balance of interpretation. Preservation bias further complicates matters. Some signals are overrepresented: volcanic ash, impact ejectabi, because they preserve well. Others, like diffuse industrial residues, are underrepresented. This bias tilts the record toward natural explanations. A civilization's faint footprints may be hidden beneath layers of more obvious natural pulses, erased by comparison, rendered invisible by louder events. The confounding pulse of nature, then, is both obstacle and teacher. It insists that we respect the complexity of Earth's history, that we do not leap too quickly from anomaly to conclusion. But it also shows us where to look. By studying volcanic events, impacts, and biological revolutions, we learn what natural signals look like, and thus what would count as excess, as surplus, as something that should not be there. The imitators define the baseline. Only against them can civilizations stand out. A gentle image arises. Imagine a symphony hall filled with instruments tuning before a concert. The sound is chaotic, overlapping, full of dissonant notes. Somewhere in the noise, a melody begins a faint, deliberate phrase. To hear it, one must know the difference between tuning and performance. Earth's record is like this: a hall of overlapping pulses, most natural, some perhaps deliberate. The task is not to silence the orchestra, but to listen more carefully, to discern whether another hand once played among the noise. Among the many signals humanity is leaving behind, plastics may be the strangest. They are substances entirely unknown to the natural world before our arrival, long chains of carbon shaped by chemistry into forms that resist decay. Light, flexible, ubiquitous, they now drift in every ocean, scatter across every continent, sink into sediments where they may persist for ages. Plastics are our accidental fossils, our polymeric shadow cast into deep time. Their fate offers a clue for how civilizations might or might not be remembered. In human time, plastics seem indestructible. Bottles and bags persist for decades. In landfills, fragments accumulate in marine gyres, broken by sunlight, into smaller and smaller pieces, but never vanishing completely. Yet on geological scales, their permanence is uncertain. Sunlight, oxygen, and microbes can fragment and metabolize them. Pressure and heat within sediments may transform them into waxy residues, carbon-rich films, or even new kinds of minerals. Some researchers speculate that plastics, once buried, could fossilize into what has been called plastaglomerate, a stone-like fusion of polymer and sand. Such formations might survive millions of years, a permanent addition to the mineral record, but even plastaglomerates face uncertainty. Over tens of millions of years, subduction and metamorphism would erase them. The polymer chains would crack, volatilize, be reincorporated into simpler hydrocarbons. What survives might not be recognizable as plastic at all, only a peculiar, carbonaceous trace, ambiguous and hard to interpret. Our plastic dreams may endure, but only in altered forms, half-ghosts of the original. The signal, then, is dual. In the near term, plastics are unmistakable markers of industrial civilization, unlike anything nature produces. In the far term, they may become indistinct, blended into geological noise. If a civilization existed millions of years ago and also used synthetic polymers, their traces may already be gone or transformed beyond recognition. Our own plastics could suffer the same fate, reduced to faint residues misread by future geologists as natural bitumen or strange organic films. A confounder must be noted. Natural tar and asphalt deposits can also leave polymeric residues. Labrie tar pits, for instance, preserve hydrocarbons in ways that might be confused with degraded plastics if one did not know their origin. Distinguishing true anthropogenic polymers from natural hydrocarbons requires precise structural analysis. Structural analysis challenging enough today, let alone in a distant future where records are incomplete. And yet, even with their fragility, plastics remain powerful as a thought experiment. They illustrate both the potential for civilizations to leave unique technosignatures and the difficulty of those signatures surviving intact. Plastics tell us that even when intelligence creates something entirely novel, the Earth works tirelessly to transform it, to fold it back into its cycles. Permanence is not guaranteed. An image emerges, a plastic bottle sinking into sand, crushed, fused with pebbles, slowly becoming a stone of mixed origin. To us, it is litter. To a geologist millions of years hence, it might be a curious rock, a hybrid of human invention and natural process. Its story may be clear, or it may be lost. The half-life of plastic is not measured in centuries, but in the uncertain patience of Earth. The implication is gentle, but sobering. If we seek civilizations before us, we must accept that even their most distinctive inventions could have dissolved, transformed, or hidden themselves within nature's own creations. Plastics remind us that memory is provisional. What feels indelible in one age becomes ambiguous in another. Our dreams, cast into polymers, may endure only as faint residues, half-lives of intention carried forward into silence. The question of ancient civilizations is entangled with a bias so pervasive it can scarcely be escaped: the bias of preservation. Earth does not record evenly. Some events are captured in exquisite detail, an insect sealed in amber, its delicate wings preserved for 100 million years, while others vanish almost instantly, leaving no trace. Preservation bias acts as a blindfold, shaping what we see and what we cannot, determining not only the survival of evidence, but also the illusions of certainty. The fossil record makes this plain. Entire lineages are missing, known only by inference because their remains never fossilized. Soft-bodied organisms are particularly elusive. Preservation depends on rare conditions, such as anoxic muds or sudden burial. What we call the Cambrian explosion may be, in part, an artifact of this bias. Soft-bodied life existed earlier, but left no record until it developed hard parts more likely to fossilize. What we interpret as a sudden flowering may instead be a sudden visibility. The same may hold true for civilizations. Their absence may reflect erasure, not non-existence. Archaeological records are similarly skewed. Sites preserved in deserts, where caves endure, those in humid forests vanish. Civilizations that built in stone are remembered. Those that built in wood, clay, or organic composites are less so. Even today, archaeologists debate the scale of ancient societies in the Amazon or Southeast Asia, their cities hidden beneath regrown forest. If our own near history is unevenly preserved, how much more distorted must the record be after millions of years? Preservation bias also magnifies some signals disproportionately. Volcanic eruptions, asteroid impacts, and mass extinctions are overrepresented because their traces are dramatic and global. Subtler events fade. If an ancient civilization never triggered a planetary crisis, it might be invisible to us now. Conversely, if it did trigger one, the signal may be present but masked by natural processes that leave similar marks. Either way, bias dictates what survives. This blindfold is not only about the physical survival of evidence, it is also about our perspective. We tend to equate absence with non-existence. But in paleontology and geology, absence is often the default. Discovery is the rare exception. The blindfold, then, is twofold: what the Earth withholds and what we assume about that withholding. To search responsibly, one must continually remind oneself that invisibility is not proof of nothingness, an analogy suggests. Itself, imagine a vast library where most books have burned, leaving only fragments. We study those fragments, reconstructing histories, building narratives. But the library is biased. It preserves only the books printed on fireproof paper or stored in rare conditions. Entire genres are gone. Entire voices are silenced. Our reconstructions are partial at best. The Earth is that library. Its catalog of civilizations, if more than one ever existed, may be forever incomplete. Red team reasoning pushes back. If preservation bias is so strong, then how could we ever hope to detect prior civilizations? Is the search not futile? Perhaps, but futility is not certainty. Even in a biased record, signals sometimes survive, and they can be compelling. Stromatolites from 3 billion years ago, whisper of microbial mats. The iridium layer at the KPG boundary points unambiguously to an asteroid. Evidence may be rare, but it is not impossible. The blindfold obscures, but it does not guarantee. Total darkness. The implication is quiet. Humility must guide our interpretations. Preservation bias tells us that silence is the rule, not the exception. It tempers certainty, softens conclusions, and reminds us that what we see is only a fraction of what was. If civilizations came before, their near erasure is expected. None did. The blindfold makes proving absence equally elusive. Either way, we walk through the archive with partial sight, groping, guessing, listening for faint echoes through layers of stone. Every speculation requires its counterweight, the careful discipline of asking, what if the opposite is true? The search for forgotten civilizations. This role belongs to the red team, to voices that remind us how powerful natural explanations are, how dangerous confirmation bias can be, and how silence, however unsatisfying, may indeed reflect emptiness. Their rebuttal is not meant to extinguish the question, but to strengthen it by showing what must be overcome to make the case persuasive. The first and strongest point is the absence of artifacts. Civilization, by its nature, builds. It reshapes landscapes, extracts metals, organizes matter. Yet in all of paleontology and geology, no unequivocal artifact older than our own species has been found. Fossils abound, stromatolites endure, meteorites are catalogued, but not one shard of pottery. No fragment of alloy, no tool, no inscription exists in strata older than a few million years. If civilizations had risen on planetary scales, the red team argues, at least some physical remnant should have survived. Their absence is telling. The second argument is that natural explanations suffice. Every anomaly invoked as a possible technosignature has a strong natural candidate. Carbon isotope excursions align with volcanism or methane release. Metal enrichments accompany impacts or hydrothermal vents. Odd minerals emerge from lightning, fire, or shock metamorphism. To invoke civilization is to multiply assumptions unnecessarily. By the principle of parsimony, natural causes should be preferred unless evidence compels otherwise. So far, no evidence compels. The third rebuttal concerns probability. If intelligence were likely to arise repeatedly, we might expect parallel cases elsewhere in the solar system, on Mars, or Venus, or icy moons with liquid oceans. Yet despite decades of exploration, no hint of civilization beyond Earth has been found. Life, perhaps. Microbial traces, maybe, but civilization seems astonishingly rare. Why should Earth alone host multiple rises of intelligence when even one appears cosmically improbable? The red team urges caution. Perhaps we are not latecomers in a cycle, but the first and only. Preservation bias is acknowledged but reframed. Yes, evidence is easily erased, but not always. Stromatolites, 3 billion years old, still survive. Zircons 4.4 billion years old endure. Dinosaur bones persist by the thousands. If civilizations had existed for millions of years, their traces, though rare, should be at least as detectable. The total absence of such traces is unlikely to be mere bad luck. It is better explained by their non-existence. Red team thinkers also warn against anthropocentrism. The tendency to imagine predecessors is a reflection of our own narrative instincts, our discomfort with uniqueness, our longing for continuity. It is psychologically appealing to imagine others before us, but science must resist such desires. The universe is not obliged to supply companions. Sometimes the answer is solitude, and yet, even as the rebuttal lands heavily, it does not end the inquiry. It defines the threshold. What kind of evidence would suffice to overturn skepticism? The answer is clear. A truly anomalous mineral, undeniably. Synthetic in strata, tens of millions of years old. A consistent global pattern of isotopic anomalies, unexplainable by volcanism or impacts. A fossil bearing evidence of artificial modification. One decisive discovery could shift the balance. Until then, the burden of proof remains unmet, and the rebuttal stands. The red team's gift is clarity. It sharpens the search, disciplines the imagination, and prevents us from mistaking yearning for evidence. Their voice is not one of dismissal, but of rigor. They remind us that silence is not only absence, but also a statement, that extraordinary claims require extraordinary signals. Until such signals appear, the simplest explanation is that humanity is alone, not only now, but always. This conclusion may feel austere, even lonely, yet austerity can also be grounding. It anchors us in what is known even as we continue to look. The red team's rebuttal is the necessary counterbalance, the weight that steadies the wings of speculation, ensuring they do not drift into fantasy. All things decay. This is not pessimism, but physics. Entropy, the tendency toward disorder, moves quietly through every structure. from the molecules of a bone to the foundations of a city. Over short spans, life and culture resist entropy by organizing matter, building walls, storing knowledge. But over geological spans, resistance always fails. Entropy is patient, inexhaustible, and unhurried. Its work is one reason civilizations ours, or any others are, unlikely to survive in recognizable form across the depths of time. A simple fact illustrates the principle. Iron rusts. Left exposed, it oxidizes, flakes, and collapses. Dunk. Aluminum weathers, even stainless steel succumbs eventually. Concrete cracks, erodes, and dissolves. Books crumble, papyrus disintegrates, data encoded in magnetic domains bleeds into noise. What we call durability is only a measure of slowness. Given enough years, entropy prevails. Biology hastens the process. Microbes metabolize organic material. Plants pry apart stone. Roots infiltrate foundations. Termites reduce wood to soil. Fungi digest paper. Human artifacts are not exempt from ecology, but quickly incorporated into it. Even our plastics, seemingly indestructible, are fragmented by light and organisms into particles that disperse. Entropy operates not only through physics but through life itself, which dismantles and reuses every resource it can reach. Geology compounds the erasure. Sediments are compressed, folded, metamorphosed. Mountains grind to gravel. Rivers carry fragments to the sea. Tectonics buries crust and melts it. Every artifact, every ruin, every city is subjected to this long recycling. Entropy ensures that matter disperses. Geology ensures that dispersal becomes permanent. A red team reflection is unavoidable. If entropy is so thorough, does it not render the very question of ancient civilizations moot? Perhaps, but not entirely. Some traces resist longer. Isotopic. Anomalies, mineral signatures, and fossilized residues endure because they are encoded in the chemistry of stone itself. They do not escape entropy, but they decay on timescales long enough to compete with it. Civilization's best hope for remembrance lies in these indirect signatures, not in its structures. Entropy's patience also explains why absence is expected. The complete lack of artifacts in the deep record is not surprising. It is the logical outcome of thermodynamics. Even a mighty civilization, if granted millions of years, would dissolve back into randomness. The silence we observe may be nothing more than entropy's slow exhalation. Smoothing away every line once drawn, the image is austere, but strangely comforting. Imagine a sandcastle built on the shore. For a moment, it is intricate, fragile, yet proud. Waves come, winds scatter, grains slip back into the sea. Hours later, nothing remains. The sandcastle has not failed. It has simply yielded to inevitability. So too with civilizations. They are brief arrangements of matter, temporary resistances to entropy. Their disappearance is not unusual. Their appearance is what is remarkable. Preservation bias, discussed earlier, is in truth an expression of entropy's unevenness. Some structures resist longer, some contexts shelter better, but the overall direction is always the same. Against this drift, even the most enduring achievements are finite. The pyramids, the Great Wall, our skyscrapers all are destined for dispersal. If we return millions of years later, nothing of them will remain. Only chemical ghosts may linger, subtle echoes of our industry. The implication is humbling. Entropy whispers that permanence is an illusion, that civilizations are transient ripples in a sea of time. Whether or not others came before, their silence is not mysterious but natural. It is the expected result of matter's tendency to scatter, to equalize, to fade. Our own silence will join theirs in time. And yet, to recognize entropy's patient work is not to despair. It is to appreciate the rarity of the moment we inhabit, the brief window in which complexity exists, organizes itself, and wonders about its predecessors. That wondering itself is a defiance. However, temporary a small flame held aloft in the wind, aware that it will one day be extinguished, yet glowing all the same. Among the great sculptors of Earth's surface, none are as patient and thorough as ice. Glaciers move with deceptive slowness, grinding mountains to powder, scouring valleys, plucking stones from bedrock, and carrying them for miles before depositing them as till. Over successive ice ages, vast regions of the continents are scraped bare, their earlier landscapes erased. For any civilization unlucky enough to lie in the path of advancing ice, the verdict is certain: near total obliteration. The Pleistocene alone saw glaciers expand and retreat repeatedly across the northern hemisphere, covering North America, Europe, and parts of Asia under sheets kilometers thick. Cities or settlements built there even our own, if abandoned, would vanish beneath the grinding mass. Stone foundations would be plucked and dragged, metals twisted and dispersed, artifacts ground into sand. What little survived would be scattered, unrecognizable, and quickly buried beneath meltwater deposits. If humanity had arisen before, during an earlier warm interlude, much of its material legacy would already be erased by glacial action. Glaciation works not only through mechanical destruction, but also through chemical reset. Meltwaters rework sediments, redistribute soils, and flush organic matter into oceans. Lakes form and drain, often catastrophically, altering entire landscapes. Glacial flour rock ground to find silt-can blanket continents, masking what lay beneath. To search for evidence of civilization in formerly glaciated regions is therefore to search in a palimpsest, a surface scraped and rewritten many times. Preservation bias emerges starkly here. Civilizations arising in ice-free refugio-tropical belts, arid zones, continental interiors would fare better in the long record than those in high latitudes. Yet human societies today cluster in temperate regions, precisely where glaciers have most often advanced. If ancient civilizations followed similar patterns, much of their evidence would have been lost to ice. What remains would be partial, displaced, or hidden beneath thick tills, difficult to excavate. Natural imitators complicate matters further. Glacial deposits can mimic certain anthropogenic signals: concentrations of metals from ground bedrock, unusual sediment layering, abrupt faunal turnovers as ecosystems shift. To misread such deposits as technosignatures would be easy unless supported by converging evidence. Ice, in this sense, not only erases, but also confuses, creating patterns that might be mistaken for industry. The red team voice is clear. If civilizations arose during ice ages, they would be nearly impossible to detect. Their absence from the record is expected, not suspicious. Lest they achieved a global industrial scale, their material traces would succumb to ice's relentless pressure. The only hope of detection would lie in indirect signals, chemical anomalies preserved in ocean sediments. Beyond the reach of glaciers, the metaphor is stark. Glaciers are like erasers on a chalkboard, pressed firmly, dragged slowly but completely, removing all markings in their path. What comes after writes on a blank surface, unaware of what was once there. Civilizations caught beneath these erasers would vanish as thoroughly as chalk dust in the air. And yet, the recognition of glacial erasure teaches humility. It reminds us that much of Earth's surface has been rewritten many times, that what we see today is only the most recent draft. The silence of earlier civilizations may not be their failure to exist, but our inability to recover what ice has taken away. The implication is quiet but unsettling. If we long to know whether others came before us, we must accept that ice has already destroyed much of the evidence. Our certainty may forever be limited, our vision bounded by the grinding patience of glaciers. What they have erased is unrecoverable. What they have spared, if anything, must be sought in the few places they could not reach. Rivers are keepers of memory, but their recollections are partial, restless, and often rewritten. They carve valleys, carry sediments, and deposit layers that can, under the right conditions, preserve exquisite details of the past. Fossils in riverine sandstones, pollen in floodplain silts, charcoal from ancient fires all whisper of vanished worlds. Yet rivers are also erasers. Their currents shift channels, scour their own beds, and wash away what they once preserved. Civilizations that lived beside rivers, as so many do, leave traces vulnerable to both preservation and destruction. Consider the Tigris and Euphrates, the Nile, the Indus, the Mississippi. These great arteries of culture provide fertile soil, transport, and sustenance, yet they are volatile. Floods deposit new layers of silt while washing away older ones. Meandering channels abandon floodplains, burying settlements beneath alluvium. Over millennia, rivers migrate widely, leaving behind cutoffs and oxbows where once people thrived. Over millions of years, entire valleys are reshaped, sediments compacted into rock, and former landscapes erased. The river remembers only fragments, and even those are often scrambled. From a geological perspective, rivers are double-edged. On one hand, they are among the best places for fossil preservation. Sudden floods can bury organisms rapidly, sealing them from decay. Ancient floodplains often yield rich fossil beds. If a civilization lived along rivers, some of its materials, pottery, bones, structures might be preserved under such layers. On the other hand, those same floods are violent, capable of dispersing evidence far downstream, fragmenting artifacts, and blending them with natural debris. The memory is vivid but unreliable, like a story retold too many times. Preservation bias magnifies the uncertainty. Rivers are selective in what they keep. Heavy objects sink and may be preserved. Lighter ones drift away or disintegrate. Organic matter decays quickly unless rapidly buried. Metals corrode in waterlogged soils. Over tens of thousands of years, even robust materials dissolve into anonymity. What survives into the geologic record is an accident of circumstance, not a systematic archive. A confounder emerges in the form of natural floods and fires. Charcoal layers might suggest human burning, but natural wildfires can produce the same. Pollen changes might suggest agricultural disturbance, but climate shifts can explain them equally well. Sediment layers thick with debris might be read as collapsed settlements, yet could equally be the product of catastrophic floods. Rivers imitate as well as remember. The image of a river as a diary is apt. Each flood, each season writes a new entry in silt and sand. Yet the diary is full of smudges, torn pages, missing lines. Reading it requires caution. Civilization's story inscribed here would be fragmentary at best, stitched together from partial clues. And over geological spans, even this diary is recycled, its pages compacted into stone, tilted, folded, and eroded. Until the writing is almost illegible, the red team voice is pragmatic. If prior civilizations left traces, rivers are poor archivists. They preserve details for archaeologists, working within tens of thousands of years, but their reliability dissolves over millions. Expecting rivers to hold memories of ancient civilizations is like expecting footprints on a beach to endure after tides. The memory is temporary, not timeless. And yet, even temporary memories can matter. If civilizations rose in the last few million years, rivers might still hold some whisper, buried in floodplains not yet eroded. If they rose deeper in time, the rivers have already forgotten, their pages recycled into stone. What remains, if anything, would be faint, subtle anomalies within ancient sandstones, unusual distributions of particles, hints requiring extraordinary interpretation. Thus, the river's memory is both promise and warning. It offers preservation in bursts, then erasure in torrents. It teaches us that time does not archive evenly, that some stories are swept away, almost as soon as they are written. To imagine civilizations along ancient rivers is to imagine voices recorded in water, fleeting, beautiful, and easily lost to the flow. Few forces reshape the earth as thoroughly as volcanism. It builds new land, buries old landscapes beneath ash and lava, alters atmospheres, and scatters signals across continents. In the search for ancient civilizations, volcanism plays a double role. It can preserve by entombment, yet it can also erase by overwriting. Its layers act as both pages and fire, writing new entries into the geologic archive while burning away the old. The preservative role is familiar. Volcanic ash can bury settlements in an instant, as at Pompeii, freezing a moment in time. Layers of tephra harden into tuff, locking in fossils, pollen, and artifacts alike. On geological timescales, ash falls may protect delicate signals by sealing them from erosion. If ancient civilizations once stood near volcanoes, their traces could, in principle, be preserved in such deposits, though only if the ash layers themselves endured without later alteration. But volcanism is more often destructive. Lava flows consume everything in their path, reducing structures to rubble, carbonizing, or vaporizing organic remains. Ash, though initially protective, can also be corrosive, its acids breaking down material. Over millions of years, volcanic layers metamorphose, recrystallize, and lose the fine details they once held. Entire landscapes vanish beneath kilometers of basalt, as in the Deccan or Siberian traps, their former surfaces sealed away, perhaps forever. Civilizations unlucky. Enough to stand there would be obliterated, their memory entombed too deep for recovery. Volcanism also complicates detection. It produces chemical and isotopic anomalies, carbon dioxide spikes, mercury enrichments, unusual mineral assemblages that mimic the very signals we might look for as evidence of civilization. The Permian-Triassic extinction bears markers that could be misread as industrial if taken out of context. Rapid carbon isotope shifts, toxic metals, global biotic collapse. Yet all were the product of volcanism on an immense scale. To distinguish civilization from volcanic activity is among the greatest interpretive challenges. Preservation. Bias tilts further against us. Volcanic provinces are vast and long-lived. They cover evidence beneath overwhelming layers, then erode unevenly, leaving scattered exposures difficult to interpret. Even when older surfaces are preserved beneath flows, accessing them requires extraordinary luck and effort. The odds of recovering traces of ancient civilizations hidden under flood basalts are vanishingly small. A red team critique sharpens the point. If industrial-scale civilizations had existed, their signals might well be indistinguishable from large, igneous provinces. Why invoke intelligence when volcanism explains the anomaly so well? Unless we find a signal volcanism cannot mimic, such as synthetic compounds or engineered isotopes, natural fire remains the simpler explanation, and yet volcanism also provides a rare gift. Its layers are time markers. Tephra spreads quickly, settling across vast regions in thin but distinctive bands. Geologists use these to synchronize records across continents. If a civilization's traces coincided with such layers, they could be precisely dated, their context sharpened. Thus volcanism, even as it overwrites, can help us map. An image comes to mind, a chalkboard written upon, then suddenly covered in black paint. The old writing is still there beneath the surface, but invisible, unreachable. The new layer becomes the dominant face, while the older words fade into obscurity. Volcanic overwrites act this way, layers stacked upon layers, each hiding what came before. The implication is quiet, sobering. If civilizations preceded us, many of their traces may now lie sealed beneath ancient basalts, altered beyond recognition. Erased by fire? Volcanism ensures that Earth's memory is selective, prone to sudden purges. Our search must accept that much has been lost not because it never existed, but because fire has written over it. The record is not empty, but overwritten, its older chapters buried under pages of stone. Even if artifacts survive fire, flood, or burial, another force waits patiently to reclaim them: life itself. Earth is a planet of recyclers. Every structure made of organic material, wood, cloth, leather, papers, swiftly broken down by bacteria, fungi, and insects. Bones are dissolved by soil acids. Shells return to carbonate cycles. Even metals are corroded by microbes that feed on them. Biological assimilation is the quiet undoing of civilization, turning every crafted thing back into nutrients, sediments, or dissolved ions. In our own world, the process is easy to observe. Abandoned buildings in humid climates are quickly overtaken. By vines, roofs collapse under the weight of moss and roots. Termites reduce timbers to dust. Within centuries, structures return to soil. On longer scales, even plastics, often considered indestructible, are slowly metabolized by specialized microbes. Human landfills, left untouched, may one day resemble fossilized reefs of altered carbon. Not because they resisted biology, but because biology transformed them into something new. This assimilation is not limited to the obvious. Entire industrial landscapes are vulnerable. Oil spills are digested by hydrocarbon-eating microbes. Concrete becomes a substrate for lichens, then weathers into gravel. Metals corrode into oxides that disperse into soils. Nuclear waste itself becomes geochemically incorporated into mineral matrices. Nothing remains pristine for long. Everything is drawn back into circulation. Life, tireless, turns the achievements of civilization into feedstock for its own continuance. The result is a record biased away from artifacts and toward chemistry. What survives of civilization is not its architecture, but its effect on biogeochemical cycles. Our own legacy may be read in carbon isotopes, in altered sediment chemistry, in shifts of biodiversity, not in the persistence of cities. The same would be true for predecessors. Their ruins would be gone, their tools long metabolized. But subtle traces might remain in how ecosystems responded. In the sudden spread of certain microbes, in disrupted nutrient balances recorded in sediments, confounder arises. Biology itself generates anomalies. Microbial blooms alter carbon ratios, oxygen levels, and trace metal concentrations without any help from intelligence. The Great Oxidation Event, driven by cyanobacteria 2 billion years ago, reshaped the entire atmosphere, leaving geochemical signals far stronger than any civilization might. To interpret assimilation as a technosignature, one must distinguish between life's natural creativity and intelligence's deliberate impact. Team critique presses harder. If biology is so efficient at reclaiming artifacts, then perhaps civilization is always doomed to invisibility beyond a few tens of thousands of years. Why imagine predecessors at all, when biology ensures their absence? The counterargument is that some signals persist even after assimilation: the isotopic echoes, the mineral residues, the anomalous distributions. Biology erases forms, but leaves shadows, and shadows, faint though they are, can be studied. The image is gentle: a fallen tree in a forest, slowly decomposed by fungi, beetles, and moss, until nothing remains but rich soil that nourishes new growth. Civilization is like that tree. Its artifacts are broken down, absorbed, repurposed, woven back into life. The cycle does not preserve the form, but it does carry forward the consequence. In this way, even erasure becomes a kind of continuity. The implication is humbling. Civilizations rose before us. Biology has likely reclaimed them, folding their achievements back into the fabric of ecosystems. Their silence is not failure, but participation in the planet's endless cycle of renewal. Our own silence will follow, not as catastrophe, but as assimilation. Our cities, our machines, our very bodies recycled into life. Remembered not in ruins, but in altered soils and sediments, subtle shifts awaiting those who know how to listen. Among the most distinctive signatures humanity has produced are the artificial isotopes created through nuclear fission and fusion. Plutonium-239, Americium-241, Cesium-137. These are not naturally abundant on Earth. Their appearance in sediments, from atmospheric weapons testing and nuclear accidents, forms a unique stratigraphic horizon, the so-called bomb spike. For future geologists, this will be an unmistakable marker of our presence, as clear as the iridium layer marking the Chicxulub impact. The question, then, is whether such signals could survive long enough to be detected millions of years from now, and whether their absence in ancient strata rules out prior civilizations. The physics offers both promise and limit. Some isotopes decay quickly. Cesium-137 vanishes within centuries. Others, like plutonium-244, have half-lives of tens of millions of years. Still others, such as uranium-235 or thorium-232, are naturally present, their artificial counterparts, indistinguishable from the background. The most promising technosignatures would be isotopes, with no stable natural analogues, persisting long enough to endure deep time, yet short enough to mark a specific window. Plutonium-244, with its 8-million-year half-life, is a candidate. Its presence in a concentrated layer could indicate artificial origin, yet preservation is not guaranteed. Radioisotopes are mobile, binding to soils, migrating with groundwater, diffusing into minerals. Over millions of years, their concentrations disperse, diluting the signal. To remain detectable, isotopes must be rapidly buried in protective sediments or mineralized into stable hosts. Even then, heat and pressure from tectonic activity can redistribute or erase them. The clock of radioisotopes ticks not only in half-lives, but also in the movements of Earth itself. Natural imitators again complicate matters. Supernova debris seeded Earth with plutonium-244 and other heavy isotopes in its early history. Cosmic rays generate radionuclides in the atmosphere. Trace amounts of many isotopes occur naturally, though rarely. To claim civilization, one would need patterns of distribution inconsistent with natural processes, concentrations, and soils, sediments or ice layers far beyond cosmic or geological expectations. Red Team. Skeptics point out that no such anomalies have been found in ancient strata. If nuclear technology had been used millions of years ago, we might expect at least scattered residues. Their absence suggests none existed, yet this argument is softened by preservation bias. Detection requires both survival of isotopes and our luck in sampling the right locations. The absence of evidence is not conclusive, though it does weigh heavily. The metaphor of a clock is apt. Radioisotopes are like luminous hands sweeping across vast spans of time. Some hands move quickly, vanishing in a blink. Others move slowly, persisting for millions of years. But eventually all fade. A nuclear civilization tens of millions of years ago would have left signals that are now muted, faint, perhaps indistinguishable from background. Only the youngest layers, within the last few million years, could hold clear anomalies. Beyond that, the clock has already wound down. The implication is both reassuring and sobering. If civilizations before us never discovered nuclear energy, they would be invisible in this register. If they did, their signals may already be gone. Our own nuclear age, however, guarantees a signature at least for tens of millions of years. Even if all our cities crumble, our isotopes will linger, marking our presence in a way stone never could. We are already inscribed in the Earth's radiological memory, ticking onward long after we are silent. Beneath our feet lie the cratons and Chansing cores of continents, fragments of Earth's earliest crust that have endured for billions of years. Unlike the restless ocean floors or the youthful volcanic provinces, these stable shields are patient, enduring, and reluctant to be erased. They are geological sanctuaries, places where the oldest rocks are preserved. If anywhere could hold whispers of civilizations older than ours, it would be here, beneath the cratons, where the silence is longest and deepest. Cratons stretch across Canada, Africa, Australia, and Siberia. Some are older than 3 billion years. Within them, minerals like zircons provide glimpses of Earth's earliest conditions, condensing, crust forming, even traces of early life. Stromatolites preserved in these ancient rocks record microbial mats billions of years gone. Such endurance suggests that if civilizations arose in deep time, their traces might be hidden within similar cratonic sediments, preserved in pockets that escaped metamorphism, yet cratons, though stable, are not invulnerable. They are often overlain by younger sediments, their older layers buried deeply. Many have undergone partial metamorphism, obscuring finer details. Accessing them requires drilling, mining, or fortunate exposure by erosion. Even then, the record is cryptic. Rocks that survive billions of years do so by being transformed, compressed, recrystallized. Whatever signals they hold are subtle, encoded in geochemistry rather than artifacts. If civilizations did arise in the deep past, the cratons are our best chance of finding them. A mineral assemblage that should not exist, an isotopic anomaly. Out of step with natural cycles, a thin layer of unusual chemistry, these would be the sorts of signals we might hope to find. But the silence of the cratons so far has been profound. They yield evidence of early microbes, tectonic activity, and planetary processes, but nothing resembling the fingerprint of advanced intelligence. The red team critique here is forceful. The cratons have spoken, and they speak only of geology and biology, not civilization. Their silence across billions of years is compelling evidence that none existed. If civilizations had risen, shouldn't at least one cratonic layer bear a decisive anomaly? The counterargument is that even within cratons, preservation is uneven. Localized civilizations might never leave global signals. Their traces could be confined to regions now eroded, buried, or altered. The silence is strong but not absolute. An image may help. Think of the craton as an ancient stone tablet, worn smooth by ages of handling. The original inscriptions are faint, some illegible, some gone entirely. What remains are scratches, fragments of letters, hints of meaning. To read them requires patience and imagination, but certainty is elusive. The tablet preserves more than other stones, yet it is still a damaged text. Its silence may conceal as much as it reveals. The implication is sobering. The cratons remind us that even the most stable places on Earth are imperfect archives. Their endurance is immense, but not infinite. If civilizations older than a few 100 million years existed, their traces would need extraordinary luck to survive in these ancient rocks. The silence below the craton is therefore both a verdict and a mystery. It weighs heavily against predecessors, yet it also teaches us that survival is rare. The quiet does not speak loudly of impossibility, and to stand upon a craton is to stand on the oldest memory Earth offers. It is to feel beneath one's feet a silence stretching back billions of years. Whether that silence is empty or full of erased stories, no one can yet say. What is certain is that the cratons hold their secrets well, guarding them in depths we have only just begun to explore. When paleontologists piece together Earth's story, they rely on the fragments of once living bodies, bones, shells, teeth, impressions in stone. These fossils provide the outlines of life's grand history, the rise of trilobites, the reign of dinosaurs, the flourishing of mammals. Yet among the billions of specimens cataloged, none show evidence of civilization. No skeletons with tools in hand, no domesticated species older than humans. No sudden appearance of anatomically modern beings lost in deep time. If civilizations once existed, they left no obvious biological trace. This absence forms one of the strongest puzzles against the hypothesis of predecessors. The fossil record, of course, is incomplete. Preservation favors the abundant, the hard-bodied, the fortunate. Entire lineages are invisible, their remains never fossilized. Soft-bodied organisms, arboreal species, and creatures in erosive habitats often vanish without record. If intelligence arose in such a lineage, its fossil presence might be minimal. Yet even so, civilization tends to amplify presence. Humans have spread globally, reshaped landscapes, left remains in every environment. Shouldn't another civilization, if it existed, have done the same? Consider tool use. Simple stone tools survive for millions of years. Homo habilis left them nearly 3 million years ago, and they persist in the record today. If an earlier civilization had used comparable implements, some trace might be expected. Yet none have been found outside the known human lineage. The red team takes this as decisive. The absence of fossils or tools indicates no predecessors. Counterarguments point again to bias. Perhaps their materials were perishable, their distribution local, their time span brief. But the silence remains loud. Domestication offers another clue. Humans have altered plants and animals dramatically in a short time. Wheat, maize, dogs, cattle are biological technosignatures reshaped by civilization, if others had engaged. In similar practices, the fossil record might reveal sudden morphological shifts, inconsistent with natural evolution. So far, no such patterns appear beyond the human story. The lineages of plants and animals flow without abrupt artificial turns, suggesting no hidden hand in their shaping. Yet here too confounders exist. Evolution itself produces abrupt, shifts-punctuated equilibria, sudden radiations after extinctions. Distinguishing domestication from natural adaptation millions of years later may be impossible. A rapid change in morphology might appear as an evolutionary burst rather than evidence of intelligence. The signal could be present but misinterpreted. The paleontological puzzle thus hinges on expectation. We expect civilization to leave abundant fossil traces, yet our expectations may be human-centered. Perhaps other civilizations were not biological in form as we know it. Perhaps they were aquatic, leaving few fossils. Perhaps they engineered ecosystems subtly, without domestication, their presence hidden in microbial lineages. If so, the fossil record would remain silent even while civilization existed. An image arises, the fossil record as a vast mosaic, composed of millions of tesserae. Most are missing, and yet the pattern still emerges. In that pattern, intelligence as we know it appears only once, in us. The mosaic shows no earlier figures, no shadowy outlines of predecessors. But with so many missing tiles, absence cannot be final proof. The pattern is compelling but incomplete. The implication is twofold. If the fossil record is taken at face value, the simplest reading is that we are the first and only civilization Earth has hosted. If, however, the record is read with humility toward its gaps, then the possibility remains unlikely, but not impossible that others came before, erased by preservation bias, misinterpreted as natural, hidden in the lacuna. The paleontological puzzle does not solve itself. It merely frames the debate. It whispers that our solitude may be real, or it may only appear so because the pieces we need are missing. When we imagine civilizations before our own, we unconsciously project human forms and technologies onto them. Stone tools, metal smelting, agriculture, combustion. Yet intelligence may not repeat our path. Evolution is inventive, and the architectures of civilization could differ radically from what we know. If predecessors existed, their works might not resemble cities or machines at all. They may have built with other materials, pursued other strategies, and left signatures we are not trained to recognize. Consider the possibility of a biological architecture. Instead of quarrying stone or forging steel, a civilization could cultivate living structures, vast fungal networks, coral-like constructs, engineered forests shaped into dwellings or tools. Such creations would be metabolically active, integrated into ecosystems, and when abandoned, they would decay seamlessly into the biosphere. Unlike pyramids or concrete, little would persist. Their memory would survive, if at all, only in genetic. Eco's unusual lineages of plants or fungi carrying traits shaped by design rather than natural selection. To us, these might appear as evolutionary oddities, not civilizational signatures, or imagine a civilization centered in oceans. Aquatic intelligence may never need fire, metallurgy, or architecture as we know it. Its achievements might lie in hydrodynamic engineering, bioluminescent communication, or genetic manipulation of marine species. Its traces would be subtle, perhaps unusual shell morphologies, engineered reefs, or biochemical residues in sediments. Yet the ocean, as we have seen, forgets quickly. Such a civilization could rise and fall, leaving only hints drowned in the recycling of seafloor crust. There is also the possibility of civilizations with minimal material footprint cultures that achieve mastery of knowledge, mathematics, or language without large-scale industry. They might not build at all, choosing paths of low ecological impact. Their legacy would be cultural, not geological, and thus entirely absent from the record. From our perspective, they would be invisible, yet in their own time they would have been real, rich, and profound. Alternative architectures challenge the assumption that civilization must look like ours. Even our Anthropocene signals plastics, radionuclides, isotopes are products of specific choices: fossil fuels, nuclear fission, mass industry, another intelligence might follow entirely different routes, leaving technosignatures we do not even know to seek. What appears to us as a natural anomaly might have been, to them, deliberate design. The Red Team critique notes that this line of thought risks unfalsifiability. If civilizations could take any form and leave any or no trace, then the hypothesis becomes immune to disproof. True, but the point is not to claim certainty, only to expand imagination. By loosening our anthropocentric assumptions, we prepare ourselves to see signals we might otherwise dismiss. The search becomes less about finding familiar ruins and more about asking, what persistent patterns might intelligence in any form leave behind? An image arises. The Earth is a canvas painted not only with straight lines and right angles, but also with spirals, fractals, and symmetries we do not recognize as artificial. Some strokes may be hidden among natural processes, indistinguishable. At first glance, only by considering alternative architectures do we realize that the canvas might contain designs too. Familiar for us to name that the implication is gentle but significant. If civilizations existed before us, they may not have resembled us at all. Their architectures could be lost in biology, drowned in oceans, or hidden in patterns mistaken for nature. Our task is not only to search the familiar but to remain open to the unfamiliar, to cultivate a sensitivity to the strange, the out of place, the unlikely. Only then can we hope to notice architectures that differ from our own. What if intelligence flowered in ways that did not rely on machines, furnaces, or factories? Our assumptions about civilization are tethered to industry harvesting energy, shaping metals, producing artifacts. Yet it is conceivable that an earlier civilization might have risen to profound heights without ever entering an industrial phase. Such a civilization would leave far subtler marks, perhaps no more than ripples in ecosystems. A trace is so faint, they would vanish into the noise of natural history. Consider a society that pursued knowledge inwardly through mathematics, philosophy, or language, without needing large-scale physical infrastructure. Their legacy would be intellectual, not material. On Earth today, oral traditions can preserve ideas for millennia without writing. Extrapolated further, one could imagine a civilization whose achievements were carried entirely in memory and culture. In geological terms, nothing would survive. Their greatness would be erased not by catastrophe, but by the silence of their chosen path. Another possibility is mastery of low-impact technologies. Instead of industry, such a civilization might have learned to work within ecosystems, cultivating plants, guiding animals, or engineering microbes in ways indistinguishable from natural evolution. Their architecture could be living, their tools organic, their waste products biodegradable. All would be reabsorbed seamlessly into the biosphere. In the fossil record, their presence might appear as minor anomalies, an unusual distribution of species, a sudden spread of a cultivated plant, a microbial lineage that shifts abruptly. But these would be difficult to distinguish from natural evolutionary events. The Red Team critique here is sharp. If a civilization leaves no detectable trace, then it is indistinguishable from non-existence. From a scientific perspective, this collapses into unfalsifiability. True, but the thought experiment remains useful. It reminds us that our search strategies are limited by our assumptions. We look for metals, isotopes, plastics, artifacts, because those are our signals. Yet other civilizations might not generate such signals at all. Their invisibility does not mean they could not have existed. It means that the geological archive is biased toward those who make noise. Preservation bias compounds this silence. Even if such a civilization altered ecosystems in detectable ways, the record might not preserve those subtleties. Climatic oscillations, volcanic eruptions, and natural extinctions produce far louder signals. Against such background, the delicate influence of a non-industrial civilization would be drowned out, indistinguishable from the fluctuations of nature. An analogy arises. Imagine a skilled musician playing a soft melody in a crowded marketplace. The song is beautiful, deliberate, but lost amid the clamor of voices, footsteps, and bells. Unless one listens with extraordinary focus, the melody goes unheard, Industrial civilizations are like that musician, real, perhaps profound, yet inaudible against the din of geology. The implication is tender, almost melancholy. If civilizations without industry once existed, they may have reached deep wisdom, creativity, and beauty, yet chosen paths that left no durable mark. Their silence today is not failure, but consequence. The earth does not preserve ideas, only impacts. To honor the possibility of such civilizations is to accept that intelligence may not always inscribe itself in stone, but sometimes in evanescence, patterns of thought, in fleeting arrangements of life, in melodies now forever gone. The question of ancient civilizations ultimately narrows to this: what minimum scale of activity must be reached before traces become detectable across geological time? Below that threshold, civilizations may live, flourish, and vanish without, leaving signals that survive millions of years. Above it, some imprint, chemical, biological, mineral, becomes inevitable. The threshold of detectability is not fixed, but it is bounded by the realities of preservation, erosion, and the creativity of nature. Our own Anthropocene provides one calibration. In just 2 centuries of industry, we have already inscribed unmistakable markers: a carbon isotope excursion, radionuclide horizons, global dispersal of plastics and metals, and a mass extinction underway. These signals are planetary in scope, unlikely to be erased quickly. Future geologists millions of years hence could identify them, provided at least some archives survive. Humanity, then, has already crossed the detectability threshold. But what of smaller civilizations? Imagine a society confined to one region, practicing metallurgy, agriculture, and modest industry. Its signals might include local soil enrichment, metal residues, charcoal layers, perhaps shifts in biodiversity. Such markers could persist for thousands of years, even tens of thousands. Yet over millions, erosion, burial, and metamorphism would erase them. Only global signals diffuse, widespread, geochemically distinctive, stand a chance of surviving into deep time. Local civilizations would fall below the threshold, lost as completely as an unrecorded thought. This reasoning also helps frame the likelihood of predecessors. For a civilization to be detectable now, it must have altered the Earth at a planetary scale, combusting carbon, dispersing metals globally, synthesizing durable compounds. Anything less would be silent to us. Today, the absence of such global anomalies in the deep record strengthens the red team position. If civilizations existed, they were likely small, brief, and undetectable. Yet detectability is not absolute. It depends on where we look and how. Might exist in places not yet sampled, or in forms not yet recognized. Our current drilling and coring of sediments is limited, biased toward certain regions. The Earth's crust is vast. Its archives are incomplete. It is possible that detectable signals exist, but have not yet been found. The threshold, then, is as much about our methods as about the civilizations themselves. An analogy arises. Think of stars in the night sky. Some are bright, visible even in cities. Others are faint, requiring dark skies or telescopes. Still others are invisible to human eyes, detectable only in other wavelengths. Civilization signals are like those stars. The bright ones, global anomalies, are visible across ages. The faint ones, local fragile imprints, are drowned out by noise. To detect them, we would need instruments tuned differently, strategies yet to be imagined. The implication is humbling. The threshold of detectability defines the boundary of what we can know. It means that even if multiple civilizations rose and fell, only those reaching planetary scales stand a chance of being remembered. All others would be erased without echo. Our own legacy, for better or worse, will almost certainly cross that threshold. Plastics, isotopes, metals, these will ensure we are remembered, if only faintly. Whether others cross the same line is the question we continue to carry. Listening for signals that rise above the noise of nature and the silence of time, 2.5 billion years ago, the Earth underwent one of its most profound transformations. The Great Oxygenation Event. Before it, the atmosphere was nearly devoid of oxygen. After it, oxygen became abundant, altering oceans, weathering rocks, and enabling the eventual rise of complex life. The event left indelible marks: banded iron formations, sulfur isotope anomalies, red beds of oxidized soils. It was a planetary revolution, but not caused by civilization. Instead, it was the work of cyanobacteria, tiny cells weaving photosynthesis. Into geology. Why consider this here? Because the Great Oxygenation provides a mirror for thinking about civilization's footprint. It shows that biology alone, without intelligence, can alter Earth at planetary scale, leaving durable signals that persist billions of years. Civilization is not unique in its ability to reshape chemistry. Microbes did it first, and far more thoroughly. If we look for anomalous signals of civilization, we must always ask, could microbes have done this? Could natural processes suffice? The answer, as the oxygenation reminds us, is often yes. The parallels are striking. The Anthropocene is marked by a sudden carbon excursion, rapid climate change, and the spread of new materials. The Great Oxygenation, too, was abrupt by geological standards, altering atmospheric composition, driving mass extinctions of anaerobic organisms, and producing novel minerals. More than 2,000 new mineral species owe their existence to oxygen introduced by life. In this sense, the oxygenation was a biological Anthropocene, a precedent showing how the planet can be remade without civilization. Red Team thinkers lean on this example heavily. They argue that if massive anomalies in the geologic record can arise from microbes, then invoking civilizations is unnecessary. Natural processes are sufficient to explain even dramatic transformations. The oxygenation is proof that planetary scale change need not imply intelligence. Civilization, then, may be indistinguishable from biology when viewed across deep time. But the mirror cuts both ways. If microbes can alter the Earth so profoundly, then civilizations, too, can be expected to leave signals, though smaller in scale, subtler, more transient. The Great Oxygenation demonstrates the durability of such transformations. Even after billions of years, the fingerprints remain. If civilizations reached planetary influence, their marks should be comparably detectable, but perhaps harder to separate from biology's louder voice. Preservation bias reappears. The oxygenation signals are clear because they were chemical, mineral, and global. They were written into iron formations, locked into rocks that endure. If civilizations chose different pathways, ephemeral, local, organic, their signals might not achieve such durability. The oxygenation sets a standard. Only those changes that permeate the geosphere broadly will be legible after vast spans of time in image forms. The Great Oxygenation as a tide turning in slow motion, staining the world with rust, painting the seas red, filling the air with a new breath. Civilization, in comparison, is a ripple upon that tide, shorter, sharper, but still inscribing itself in chemistry. The mirror reminds us of scale and of humility. Our presence is large to us, but small against the background of life's planetary revolutions. The implication is quiet. When searching for ancient civilizations, we must learn to distinguish between the deliberate and the microbial, the cultural and the biological. Yet we must also accept that the two may blur. Civilization itself is an extension of biology, one more experiment in Earth's long creativity. To see the Great Oxygenation as a mirror is to recognize that even if we are alone, we are not unprecedented. In altering the world, others tiny, ancient, unknowing, came before, and their signals are still with us. 56 million years ago, Earth experienced a sudden and dramatic warming known as the Paleocene thermal maximum PET. Temperatures rose by 5 to 8 degrees Celsius in a geologic instant. Ocean chemistry shifted. Deep waters became acidic. Ecosystems were disrupted worldwide. In the geologic record, the PETM appears as a sharp negative carbon isotope excursion, a rapid release of light carbon into the atmosphere and oceans. To this day, its cause is debated. The leading explanations are natural, volcanic activity in the North Atlantic, destabilization of methane hydrates, oxidation of organic-rich sediments. Each could release massive amounts of carbon quickly enough to drive the observed anomaly. Yet none are without uncertainty. The exact trigger, scale, and sequence of events remain elusive. The PETM is, in some ways, a geologic mystery one that happens to look uncannily like the signal humanity is currently inscribing in the Anthropocene. This resemblance has not gone unnoticed. If future geologists were to study the Anthropocene without historical knowledge, they might interpret it as a PETM-like event, a sudden injection of carbon, a rapid warming, a biodiversity crisis. They might ascribe it to volcanism or methane, never suspecting civilization. By analogy, could the PETM itself conceal a technological cause? Could it be the faint echo of a civilization that burned carbon at planetary scale long before us? Red Team reasoning objects strongly. The PETM is explainable without civilization. Methane hydrates, once destabilized, could account for the isotope anomaly. Volcanic intrusions into carbon-rich sediments could do the same. To invoke intelligence is unnecessary. Moreover, no accompanying technosignatures, metals, synthetic compounds, anomalous minerals have been found. The simplest explanation is natural, and so it is favored. Yet the PETM remains instructive. It shows how easily civilization's signal could be mistaken for nature. Our own carbon spike, viewed tens of millions of years hence, might look identical to the PMA, without plastics, isotopes, or radionuclides preserved. Future geologists could read our moment as volcanic or geologic in origin. The PETMA teaches humility. Even if civilizations left signals, you may not recognize them for what they are. Preservation bias deepens the enigma. Ocean sediments from the PETM are limited, often reworked or incomplete. Oh, what evidence we do have may not represent the whole picture. If subtle technosignatures were present, they may already be lost. What remains is a global chemical anomaly, open to interpretation, but dominated by natural explanations. Civilization, if it existed, would be hidden beneath geology's louder voices. The analogy is quiet. Imagine standing in a forest after a great fire. The ground is scorched, trees are gone, the air smells of ash. Was the fire sparked by lightning or by human hands? After enough time, the distinction may be impossible to prove. The forest tells of fire, but not of cause. Is such a forest preserved in stone? It tells us of carbon and heat, but not why. The implication is subtle. Whether or not the PETM hides a predecessor civilization, it shows us that our own legacy may be similarly obscured. If we vanish, our anomaly may blend into the chorus of natural events, another mysterious warming in the archive. The PETM reminds us that certainty is fragile, interpretation biased, and deep time indifferent to our desire for clarity. It is both a warning and a mirror, whispering that even if civilizations exist, they may always be mistaken for nature's own turbulence. Throughout Earth's history, life has been punctuated by extinctions, abrupt reductions in biodiversity. That reset the course of evolution. Some were catastrophic, eliminating the majority of species in a geological blink. Others were subtler, smaller pulses lost in the ebb and flow of ecosystems. All are written in stone, in the thinning of fossil. Diversity, in the sudden disappearance of lineages. The question is whether any of these shadowed signals might conceal the hand of civilization. The 5 great mass extinctions are well known: the Ordovician-Silurian, Devonian, Permian-Triassic, Triassic-Jurassic, and Cretaceous-Paleogene. Each is linked to natural causes: glaciation, volcanism, impacts, climate shifts. The Permian, the most severe, is attributed to Siberian volcanism, releasing greenhouse gases. The Cretaceous is tied to an asteroid strike. Each is a natural upheaval, yet their violence resembles what unchecked civilization might cause: warming, acidification, collapse of food webs. It is tempting to wonder whether, hidden among these, one might not be natural at all. Smaller extinctions provide even more ambiguity. The mid-Pleistocene extinctions, the Eocene-Oligocene transition, The smaller biotic turnovers in the Devonian all show patterns of biodiversity. Loss less clearly linked to singular natural events. Could one of these represent ecological collapse triggered by civilization over exploitation, industrial pollution, or climatic destabilization? The fossil record alone rarely distinguishes intent from accident, shows only absence. Vanished. Species, truncated lineages, a quieting of the biosphere. Red team reasoning presses here. Extinctions are common. Life is vulnerable to volcanism, climate impacts, sea level change. No extinction requires civilization to explain it. Moreover, the fossil record provides no evidence of artificial selectivity, no sudden disappearance. Of large domesticable species, no abrupt shifts in agricultural ecosystems. Without such specificity, extinctions remain safely attributable to nature. Civilization, if present, hides too well within the broader pattern. And yet, extinctions illustrate detectability thresholds. A small, localized civilization might vanish, without global ecological impact, leaving no extinction trace. A global civilization, however, would almost inevitably trigger extinctions through habitat loss, climate disruption, or resource consumption. Our own Anthropocene is already producing one. Amphibians, insects, mammals, and plants declining at rates unseen outside mass extinction events. If others reached similar scales, their collapse might likewise appear as a sudden thinning of diversity. The absence of distinctive extinction signatures argues against predecessors of our scale, but not against smaller ones. An image arises, the fossil record as a night sky. Each species a star. Extinctions are sudden dark patches where constellations fade. Most of the time, the cause is natural, a supernova, a shifting cloud. But occasionally, one might imagine a hand drawing curtains across part of the sky. The difference is real, yet indistinguishable from afar. The fossil record tells us which stars went out, but rarely why. Preservation bias further blurs the picture. Many species leave no fossil trace at all. Most extinctions are undercounted, their severity misjudged. The apparent suddenness of an event may reflect gaps rather than reality. A civilization-induced extinction, if subtle, might dissolve into these uncertainties, its signal irretrievable. The implication is gentle, but sobering. Extinctions show us both the fragility of life and the difficulty of assigning cause. They remind us that civilization's shadow, if it fell before, might be visible only as absence of thinning of diversity without clear reason. The silence of the fossil record may not be emptiness, but ambiguity. Civilizations may vanish not only without ruins, but without attribution. Their only legacy a shadowed signal in the tapestry of life. Sometimes the earth whispers not through bones or fossils, but through chemistry's light imbalances, curious enrichments, ratios that do not fit natural cycles. These geochemical anomalies are scattered across the record, and they are among the most promising places to search for lost civilizations. Unlike artifacts, which vanish, or fossils, which are selective, chemical signatures can spread globally and persist for millions of years. They are the planet's own notations, inscribed in stone. Examples abound. Mercury spikes occur at the Permian-Triassic boundary, interpreted as volcanic emissions. Iridium enrichment at the Cretaceous-Paleogene marks an asteroid impact. Sulfur isotope anomalies trace microbial metabolisms in ancient oceans. Carbon isotopes swing with mass, extinctions, and climate shifts. Each is natural, yet each shows how sensitive Earth's chemistry is to disturbance. If civilizations altered the environment at scale, they too would leave anomalies, subtle but potentially recognizable. What forms might these take? Elevated levels of metals in unusual contexts, lead, chromium, cadmium, or rare earth elements, distributed far beyond natural or deposits. Isotopic ratios inconsistent with known volcanic or biological processes. Novel compounds, perhaps transformed, but still recognizable, such as fluorinated molecules or halogenated organics. Each would stand out against the baseline, though not without ambiguity. The difficulty lies in interpretation. Volcanism, impacts, and microbial innovations can mimic many of these signatures. Distinguishing civilization requires convergence. Multiple anomalies aligned in time and space, pointing toward deliberate processes rather than natural accidents. A carbon excursion alone is insufficient. Paired with unusual metal distributions and synthetic residues, it becomes harder to dismiss. Evidence ladder demands redundancy. Preservation bias shapes the record here too. Some anomalies are overprinted, diffused, or erased by later events. Others survive only in specific depositional environments: quiet basins, deep sediments, anoxic zones. Our sampling of these archives is limited, biased toward accessible outcrops and drilled cores. There may be anomalies we have not yet seen, simply because we have not looked in the right places, eh? Red Team critique emphasizes parsimony. Every anomaly studied so far has a plausible natural explanation. None requires civilization. To claim otherwise is to misapply imagination. Until a truly inexplicable pattern emerges, the natural must suffice. This is a strong point, but it does not close the question. It only defines the burden of proof. An image may help. The Earth as a musical score, its chemistry, the notes. Most notes follow familiar scales: volcano, impact, evolution. Occasionally a discordant chord appears, jarring, unresolved. Natural explanations exist, but the possibility remains that some chords were played by other hands. To recognize them requires not only listening, but knowing what music can be. The implication is quiet. Geochemical anomalies remind us that the Earth is sensitive to disturbance, and that disturbances are recorded. If civilizations before us existed, their presence may still echo faintly in these chemical signatures, awaiting recognition. If none did, then the anomalies remain as testimonies to nature's own creativity. Either way, the score continues. Its notes inscribed in stone, waiting for those patient enough to read them. Not all evidence is written in stone or sediment. Some of it may still drift above us, in the thin and restless film of atmosphere. Civilizations alter air. They burn fuels, release chemicals, and change the composition of gases. Our own presence is already detectable from space. Carbon dioxide, methane, nitrous oxide, all elevated beyond natural baselines. Synthetic compounds such as chlorofluorocarbons linger, wholly absent from pre-industrial atmospheres. If civilizations came before, could their echoes remain aloft, frozen in ice, or trapped in sediments, waiting to be read? Atmosphere is a poor archivist in real time. Winds mix its contents within months. Molecules disperse quickly, reactions dismantle them, sunlight fragments them, yet air can be stored. Snow traps, bubbles that compress into ice, archiving atmospheres for hundreds of thousands of years. Sediments absorb gases or preserve the chemical consequences of their presence. Ancient soils capture isotopic ratios reflective of atmospheric conditions. And these indirect vaults, signals of civilizations, might persist. What might we seek? Carbon dioxide levels far out of line with volcanism. Methane spikes too abrupt for wetlands alone. Halogenated compounds with no natural origin. Oxygen fluctuations inconsistent with known biological cycles. Each could point toward intelligent activity, yet each has confounders. Volcanoes alter carbon and sulfur. Methane hydrates release suddenly under warming. Lightning, wildfires, and cosmic rays drive small anomalies. To claim civilization requires more than anomaly, requires a chorus of anomalies, synchronized, global, and implausible as mere accident. Our own sky illustrates the principle. The Keeling curve records the steep rise of carbon dioxide in the past century, a slope sharper than any in hundreds of thousands of years. Paired with synthetic compounds like CFCs, this creates a clear technognature, such a signal. Were found in ancient ice or soil, unexplained by natural cycles, it would demand attention. But preservation limits us. No ice older than about 1 million years survives. Beyond that, atmospheric archives are indirect, written only in stone. Red Team voices point to this transience. Atmospheric signals vanish quickly compared to geological time. Even strong technosignatures would fade within hundreds of thousands of years, erased by chemistry and circulation. The absence of ancient anomalies, then, is expected. Civilization leaves little in the sky that can last. The air is not a patient medium. It forgets almost as soon as it learns. And yet, there is poetry in this forgetting. The atmosphere is like a chalkboard written on constantly, erased each day by wind and light, yet occasionally preserving faint smudges in the ice below. To search the sky for civilizations is to search those smudges, delicate and incomplete. Hoping for a trace that lingers, the implication is bittersweet. If civilizations came before, their breath has long since been exhaled. Their smoke dispersed, their compounds dismantled by the patient chemistry of air. Only indirect witnesses remain: soils, sediments, isotopes. The sky keeps no long memory. It is a messenger for the present, not the past. To know earlier civilizations, we must look downward, into stone, not upward. The signals from the sky are fleeting, a voice carried briefly on the wind, then gone. When humanity drills into the earth for oil, gas, and coal, we are not only extracting energy, we are also excavating memory. These fuels are the condensed sunlight of vanished forests and oceans, compressed into seams and reservoirs. Their abundance tells of ages of growth, burial, and preservation, and their very presence, intact and untapped until now, may itself be an argument against earlier industrial civilizations. If predecessors had once risen to global scale, they too might have discovered fossil fuels. Like us, they might have burned them, unleashing stored carbon, altering climate, and inscribing their activity into the geological record. Yet the reservoirs we exploit today are vast, seemingly untouched. The coal seams of the Carboniferous, the oil fields of the Mesozoic and Cenozoic. The natural gas deposits deep underground, these remain full as though no one before us had drawn them down. Their silence is striking. This observation forms a powerful red team critique. If advanced civilizations had existed in the last few 100 million years, they would likely have used fossil fuels. Industrialization almost demands it. Concentrated, portable energy enabling large-scale growth. But fossil fuel deposits show no sign of prior exploitation. They remain continuous, consistent with natural accumulation. No gaps, no absences, no anomalies betray ancient extraction. Their untouched state suggests we are the first to discover and use them, yet there are subtler possibilities. Perhaps earlier civilizations did not rely on fossil fuels. They may have harnessed other energy sources: geothermal, solar, tidal, nuclear. Or perhaps their scale was small enough that they left no lasting dent in reserves. A brief industrial episode might consume local deposits, leaving global patterns largely intact. Preservation bias, too, complicates matters. Depleted seams could be reburied, altered, or hidden by tectonics. The absence of evidence is strong, but not absolute. Still, the fossil fuels are persuasive because they are so visible. We measure their abundance, map their extent, chart their chemistry. If gaps existed, absent is inconsistent with natural processes, they might have drawn attention. Their continuity strengthens the case for our uniqueness. The silence of the fossil fuels is not like the silence of artifacts, which can be explained by erosion or biology. It is a silence in resources that should have been consumed if others had burned them. This silence feels louder. An analogy helps. Imagine entering a vast banquet hall laid with food. If generations had feasted here before, one would expect signs: missing dishes, empty plates, altered arrangements. But the hall is full, untouched. This does not prove no one ever came, but it makes their absence more likely. Fossil fuels are Earth's banquet, and so far they look unvisited. The implication is sobering. The untouched state of fossil fuels suggests that, at least in the last few 100 million years, no predecessors rose to industrial scale. Smaller civilizations remain possible, fleeting, and undetectable. But global industry, with its appetite for carbon, seems absent. The silence of the fossil fuels is a silence of consumption not made, a banquet not yet disturbed. It may be one of the strongest arguments that we are indeed the first of our kind, even if an ancient civilization left a signature an isotope anomaly. A peculiar mineral, a faint chemical trace, it would not appear in the record as a story. It would appear as a single signal, lonely, detached, surrounded by noise. A spike here, a shift there. Scientists would debate it, compare it to volcanism or impacts, and in most cases, decide upon natural explanations. One lonely signal, without companions, is never enough. The archive of Earth requires convergence for conviction. This is the heart of the difficulty. Civilization is ephemeral, while geology is immense. The odds that multiple signals survive together, aligned in space and time, are low. One artifact might be dismissed as contamination. One chemical anomaly might be read as volcanism. One isotopic excursion might be methane release. For intelligence to be recognized, it must speak in chords, not single notes. Otherwise, its voice is lost in the choir of natural processes. The Red Team thrives on this loneliness. They point out that every anomaly so far has been explainable without invoking civilization. The Petem carbon shift, the Permian mercury spikes, the Cretaceous iridium layer all have natural causes sufficient to account for them. To interpret any as evidence of intelligence is to abandon parsimony. Without multiple lines of evidence, converging the lonely signal is only a curiosity, not a revelation. And yet loneliness does not mean irrelevance. A lonely signal may be a seed, a hint awaiting connection. If several lonely signals, separated in different records, were ever found to align a metal anomaly here, an isotopic excursion there, a peculiar mineral in the same horizon there, convergence might transform speculation into plausibility. Science builds not on single data points, but on patterns. The lonely signal waits for its companions. Preservation bias explains the scarcity. Signals are fragile, easily erased. 4. Most ancient civilizations, if they existed, only fragments would survive. Their record would not be full or clear, but scattered like whispers in the wind. Expecting a complete story is unreasonable. Hoping for even one aligned chord is ambitious. The loneliness of the signal is not surprising, it is the default. An image arises. A night sky with a single star visible through clouds. One cannot know whether it belongs to a constellation, whether others surround it unseen. It may be isolated, or it may be part of a grander pattern hidden from view. The lonely star tells us little alone, yet it suggests the possibility of more. The lonely signal in Earth's record is such a star. The implication is quiet. Civilizations came before. Their presence may now be reduced to lonely signals anomalies, debated, dismissed, unresolved. Perhaps we have already seen them, cataloged them as oddities, filed them under unexplained natural events. Perhaps they are waiting, not to be discovered anew, but to be reinterpreted, to be recognized as belonging to a different story. Or perhaps there are none at all, and the anomalies are only Earth's own restlessness. Either way, the loneliness of the signal teaches humility, reminds us how easily memory fades, how faint intelligence may appear when stretched across deep time. In geology, there is a concept both elegant and unsettling: the unconformity. These are surfaces in rock where time itself is missing, erased by erosion, or never recorded at all. A layer may leap from one age to another, with millions of years absent in between. The record is not continuous but broken, its horizons erased. For the search for civilizations, unconformities loom large. They are not merely gaps in stone. They are blindfolds, hiding whatever stories might have been written in the missing pages. Famous examples remind us of the scale of erasure. The Great Unconformity in the Grand Canyon spans over 1 billion years, where ancient rocks are overlain directly by much younger strata. What happened in those lost ages? Tectonics, erosion, and glaciation removed everything, leaving silence where history might have been. Other unconformities exist across continents, each a reminder that the rock record is less a book than a fragmented anthology, the entire volumes missing. For civilizations, this is decisive. If any arose during such missing spans, their traces would be gone entirely, scraped away before being buried. No fossils, no artifacts, no chemical anomalies would remain. The absence we observe may not reflect absence in reality, but only the tyranny of unconformities. Our confidence in deep history is built on incomplete text, with vast stretches of the story absent. The red team argument acknowledges this, but turns it to skepticism. If civilizations arose only in the erased horizons, then they are by definition undetectable beyond science's reach. The hypothesis becomes unfalsifiable. Better, they argue, to assume none existed at all than to anchor hope in gaps that can never be filled. Silence is silence, and the unconformity is final. Yet the presence of unconformities does not erase their importance. They remind us to treat absence with caution, to resist drawing conclusions from missing data. They also redirect the search. Instead of asking what is absent, we ask what is preserved, where the record is continuous. What signals remain, what anomalies survive. Civilization, if it leaves traces, must be sought in those preserved slivers between erasures. Not in the voids themselves. An image emerges, a film reel with frames missing. The story jumps suddenly, characters changed, scenes altered. One cannot know what occurred in the missing frames, but one can sense the discontinuity. The unconformities of geology are such jump cuts. They are evidence not of continuity, but of disruption. Reminders that the film of Earth's history is incomplete. The implication is sobering. Erased horizons ensure that certainty will always elude us. We can never know whether civilizations existed during those missing spans. The gaps are too wide, the loss is too total. What we have is only the surviving fragments stitched together across erasures. Whether those fragments contain enough to answer the question remains uncertain. The unconformities tell us that forgetting is not an accident of Earth, it is its nature. Time is not a continuous archive, but a manuscript half-burned, half-scattered, leaving us to read between the gaps. When we imagine ancient civilizations, we inevitably use ourselves as the template. Our Anthropocene, with its plastics, isotopes, skyscrapers, and satellites, becomes the model of what civilization must look like. This is the bias of the present hour tendency to assume that intelligence elsewhere, or elsewhen, would manifest in ways familiar to us, yet this assumption may blind us to subtler or stranger signals, leaving us unable to recognize traces that do not match our reflection. Consider energy. Our civilization is built on combustion and electricity, but another might have drawn power from tides, from controlled biology, from low-impact solar collection. Such strategies could be less geochemically disruptive, leaving fewer anomalies. We expect isotopic excursions because we create them. We expect synthetic compounds because we manufacture them. Yet a civilization without these choices would leave different marks, perhaps ones we are not trained to notice. Consider materials. We shape metals, polymers, ceramics. But another civilization might have used transient materials, biodegradable composites, engineered tissues, living structures. These would vanish quickly, absorbed into ecosystems without durable residue. To us, such a civilization would appear invisible, even though in its own time it was vibrant and advanced. Our expectation of ruined stone, steel, glass becomes a filter that excludes other possibilities. Even our sense of scale is biased. We imagine civilization as global, industrial, transformative. Yet intelligence might flourish at smaller scales, regional, ecological, ephemeral. A culture lasting hundreds of thousands of years, sustainable and modest, might never cross the detectability threshold. We assume that intelligence inevitably expands, but perhaps this is a peculiarity of our own path. The Earth may have hosted civilizations that chose differently, durable in time, visible in geology. The red team critique uses this bias as a counterargument. If civilizations could be so different that they leave no traces, then the question becomes untestable. Better to assume absence until positive evidence appears. This is rigorous, but it risks blindness. The bias of the present does not mean any anomaly is civilization. It means we must widen our sense of what counts as a signal. We must learn to search not only for ourselves in the mirror, but for others unlike us. An analogy arises. Imagine walking through a forest looking only for footprints like your own. Deer, birds, insects, and countless other beings pass unseen. Their traces overlooked because they do not match your expectation. The bias of the present makes us hunters of likeness, not listeners to difference. Civilization may be present in forms we have not yet taught ourselves to perceive. The implication is both humbling and liberating. Humbling because it reveals how narrow our vision is, how easily we mistake absence for certainty. Liberating because it invites imagination new ways of thinking about intelligence, new signatures to search for, new openness to possibility. The bias of the present is a blindfold, but also a reminder that to ask if others came before, we must learn to look beyond ourselves. Time does not flow evenly for civilizations and for planets. To us, 10,000 years feels immense stretching from the first cities to the present. To geology, it is a blink, a layer of dust, a ripple in sediment. Civilizations rise quickly, leave signals briefly, then fade into silence. Planets, by contrast, endure, recycling, erasing, recording in ways alien to our scales of thought. This asymmetry of time is at the heart of why the question of predecessors is so difficult to answer. Consider our own moment. In mere centuries, we have transformed the atmosphere, redistributed metals, synthesized plastics, scattered radionuclides. These will linger, but not indefinitely. Plastics may last millions of years in altered forms. Radionuclides will decay. Isotopic signals will blur. Within tens of millions of years, much of our presence will be reduced to ambiguous traces. Our civilization, though global, is short compared to the planet's rhythms. Its memory of us will be partial, incomplete, vulnerable to interpretation. Now extend this asymmetry to earlier civilizations if they existed. Even long-lived societies lasting millions of years would still occupy only thin slices of geological time. Their signals might be brief spikes in the record, narrow bands in stone. Against the vastness of Earth's 4.5 billion years, these would be rare and fragile. Missing them would not be surprising. Interpreting them would be uncertain. The asymmetry ensures that civilizations are always outnumbered by silence, red team. Reasoning builds on this. If civilizations are so brief, then their probability of overlapping with preserved records is low. Add preservation bias, erosion, and unconformities, and the odds diminish further. Expecting to find traces may be unrealistic. The asymmetry of time favors forgetting. Civilizations may flare often or rarely, but either way, their signatures are swallowed by the immensity of geological processes. Yet asymmetry also sharpens perspective. It teaches us that absence of evidence is not evidence of absence. The timescales simply do not align. Civilization's fragile presence is always at risk of being missed. The Earth is patient. Civilizations are hurried. What we seek are the footprints of sprinters on a beach where tides have rolled for billions of years. An image suggests itself. Fireflies over a meadow at night. Each lights briefly, then vanishes. The meadow itself endures, vast and dark and different. To the momentary flashes, if one returned hours later, or centuries, the meadow would look unchanged. The fireflies would be gone, their light forgotten. Civilizations are such flashes. The Earth is the meadow. The implication is gentle, almost tender. Whether or not civilizations came before us, the asymmetry of time guarantees that most would be invisible now. Their traces, if any survive, are rare exceptions. Our own future is similar. We, too, will fade into ambiguity. What remains may be a few signals, enough to suggest we were here, but not enough to capture what we were. To see this clearly is to accept that time does not keep our scale, keeps its own, vast and slow, against which civilizations are brief illuminations, bright, real, but soon forgotten. If, after all searching, all comparisons, all debates, the evidence for predecessors remains absent, then we are left with a profound possibility that we are the first. The silence of the rocks, the continuity of fossil fuels, the lack of artifacts, the plausibility of natural explanations, all converge toward solitude. To stand as the only civilization Earth has ever produced is both exalting and sobering. A realization heavy with consequence, The weight of this solitude rests in responsibility. If no others have come before, then the experiment of civilization has been run only once. There are no predecessors whose stories might guide us, no examples of success or failure to learn from. Our path is without precedent. That makes it fragile. Extinction is the norm in evolution. Survival is the exception. If we falter, the Earth may not produce another chance. The silence behind us is a reminder of what could be lost if we too. Fade.Red Team voices support this view. The absence of clear technognatures across hundreds of millions of years is strong evidence of uniqueness. Scale or rare, perhaps vanishingly so. Intelligence may not be an inevitable outcome of evolution, but an improbable accident. To exist, then, is extraordinary. The solitude is not emptiness. It is a measure of improbability, of rarity. We are a singular experiment in a vast history otherwise content with microbes, forests, and dinosaurs. And yet solitude is not only burden, it is also wonder. To be the first is to be the beginning of a story, not its continuation. We are not latecomers to a grand procession, we are the opening chapter. Our Anthropocene is not a repetition but a novelty, a new signal inscribed upon the planet. The absence of predecessors makes our presence no less real, no less luminous. It makes it all the more remarkable. An image arises, a lone flame in a cavern. Casting light on walls that have never known fire, the darkness is immense, but the flame is undeniable. Its solitude does not diminish it, it defines it. The Earth has carried life for billions of years, yet only now, perhaps only once, has it carried civilization. To bear that weight is daunting, but also beautiful. The implication is quiet. If we are alone, then our choices matter more than we often allow. We are not repeating a cycle, but making one. We are not echoes, but origin. The silence of the Earth behind us is not disparate, is invitation. To carry forward intelligence, to shape it with care, to leave a legacy worth remembering. Even if memory itself is fragile, the weight of solitude is heavy. But it is also clarity, tells us. You are here, perhaps the first, perhaps the only. Do not waste the chance, even if the silence means no predecessors, or if it means their traces are forever erased. The possibility remains that civilization is not a singular event, but a recurring one. If intelligence can arise once, it may arise again. Perhaps not soon, perhaps not in human form, but given time, evolution may once more produce beings who wonder, who build, who ask questions of the stone. Civilizations may return, each unaware of the others, each believing itself alone. This possibility softens solitude. It reframes absence not as emptiness, but as interval. The Earth has endured extinctions and recoveries. It has seen forests rise, deserts spread, oceans advance and retreat. In each cycle, life renews itself, experimenting endlessly. Intelligence, though improbable, may be one of those experiments, surfacing occasionally like a rare bloom. If so, then we are part of a rhythm, not an exception. Our Anthropocene would be one flare in a longer sequence of flares, brief but recurring. The detectability problem ensures that such cycles would appear isolated. Each civilization, erased by time, would leave little to guide the next. The result is an Earth that hosts intelligence again and again, yet with no continuity, no memory across epochs. Each rise is a new beginning, ignorant of what came before. The silence of the past becomes not proof of absence, but proof of forgetting. Red Team. Reasoning sees little comfort in this. They argue that the rarity of intelligence makes repetition unlikely. Civilizations may not return. Extinction may be permanent. Silence may stretch not only behind us, but ahead, unbroken. Yet probability is not certainty. Evolution's creativity is vast, and time is abundant. Over another billion years, the Earth may yet surprise itself. The image is gentle, a meadow where rare flowers bloom only once in centuries. Each blossom fades, leaving no seed to carry forward, yet the meadow endures, and eventually another flower rises. The blooms do not remember one another, but the meadow does. Earth is that meadow. Civilizations may be its rare blossoms. The implication is tender. Whether we are first or alone matters less than what we do now. Our presence may be fleeting, but it is real. To live as if we are the only, yet to act as if others may one day come, is to honor both solitude and continuity. The possibility of return reminds us that silence is not final, it is pause. And within that pause, we are the ones who breathe, build, and wonder. The question fades, like light receding across water. What if we are not the first? What if we are? The earth does not answer. It moves on, shifting plates, folding mountains, erasing and writing anew. Its silence is neither confirmation nor denial. It is simply the nature of time. You sit with this silence. It stretches, patient, older than memory, older than thought. Civilizations, if they came before, are gone. Civilizations, if they never came, are still absent. What remains is the present, this breath, this awareness, this moment of wondering. The rocks beneath you are indifferent yet immense. They have held oceans, forests, deserts, glaciers. They have carried fire and ice, life and extinction. They will carry whatever comes after. To touch them is to touch continuity, not certainty. Their quiet weight reminds you that permanence is illusion. But existence, brief as it is, enough an image lingers. Fireflies over a meadow, each glowing for a moment, then gone.
Perhaps
There were others before. Perhaps there will be others. Again, their light does not last, yet it is real when it shines. So too with civilizations. So too with us. In the end, the question is less about evidence than about perspective. To wonder whether others came before is to feel the scale of time. To measure our briefness against billions of years and to find humility there, it is to rest within uncertainty without needing resolution. The earth holds its secrets. We hold our questions. Between them lies a stillness that soothes you. Breathe. The silence deepens. The question dissolves, leaving only the rhythm of stone, of ocean, of time itself. There is no urgency here, no answer to chase, only quiet, patient, enduring calm.